friends, I Abhinav Negi welcome you all on BYJU'S exam prep guys, and in this session guys we'll be doing the complete marathon of highway engineering, whether it is stopping side distance, whether it is super elevation, extra widening, length of vertical curves, traffic, volume, rotary, design, pavement design, ESWL, EALF, rigid joints, contraction joints, everything we'll be doing complete in this session. Okay, I hope that till now you are having a fantastic Sunday, and I will make sure that the next few hours are even more brighter, more sunnier. Yes guys, we'll be going chapter wise, okay, and between we'll be doing the questions as well guys. Excellent commandos. Okay, so after the class guys, I'll be providing you the PDF as well. Whatever I am writing here now, whatever I am writing here, everything I'll be providing you the PDF. Okay, so whatever my ink will be, everything will be getting there guys. And guys, to make the maximum of this session, okay guys, might be some of you are sitting in the bed and watching me on the mobile. To get the maximum of this session guys, one small request from my side guys, if possible then watch the session in the bigger screen. Okay, watch the session in the big screen, maybe connect with the TV, maybe connect with the laptop. Okay, and if it is not possible, then yes, you can watch on the mobile also guys, if you genuinely want to tell, because we are going for the few hours next. Okay, so watching for next few hours in mobile, it is better that if available then watch it in big screen. Okay, next guys, that you don't have to write whatever I am writing here. Okay, because whatever I'm writing here I'll be providing in the PDF. Okay, if any other point which is not written here but is coming from my mouth and you like it, of course that point you can write down on your copy. And guys, please ready with pen, copy and calculator with you, so that in between if you want to write some notes, or when I'll be giving question, you can solve them to make the maximum of it and be in a sitting position so that you can be attentive. Okay, this is about me guys, but if I'm from IT Delhi, I have 11 plus years of teaching experience, or I'm already like 164 or 1,64,000, that doesn't matter. Whatever I'm teaching you, if you're getting that is much more important than all these credentials. Okay, this is the app series guys, the complete OCF exactly like paid course. I'm teaching on app guys. The series is started. Okay, we have completed chapter 1. Now from Monday chapter 2 will be coming, so you can join then and you can see the earlier classes as well on Sunday evening. Okay, and guys, below this video, below every video of mine on YouTube, you will be finding a link here. Okay, you can click this link and download our app for free, where you will get the notes, PYQs of HPCL, PYQs of ISRO, BA, GATE, ESC, notes, everything from this link. Okay, this is my Telegram group. Already guys, more than 5,600 students have joined this family. You can also be a part of this family, so you can get the notes, the links, the updates, everything here in the Telegram group. Okay guys, well, we are going to start. This is the GATE syllabus. Okay, this is geometric design, this is traffic engineering, and we'll be doing this in combined one chapter na? Okay, now guys, in any competition exam, let me tell you, the 40% weightage or even 45% weightage is from geometric design. From traffic engineering guys, it is around 35% or 40% weightage. Okay, 35 or around 40% weightage. And from pavement design and pavement material combinedly, it is around 15% weightage. Okay, and of course guys, no need to go for the book in the last moment. But if you are a third year student, okay, you have ample amount of time, then this is the best book. This is the best book for highway engineering, that is Khanna and Justo. Okay, but it is only for those who will be giving GATE in 2025 or 26. If you are giving in GATE 2024, then of course that whole book is not at all required, but otherwise this whole book you can do in only 15 to 20 days. They can go for the notes. Okay, but yes, if you are aiming for 25, 26, 2026, then you can go for this book. Okay, सर आप क्या इस सेशन को नोट्स प्रोवाइड करेंगे? यस अंश, whatever I'll be doing here ना, I'll be providing that. Yes Bharat, ready. Bharat Reddy was the first to join the class, I guess. Okay, start ho gaya bhai. Good morning Nandu, good morning. Whatever in the gate, I'll be telling you guys. Okay, guys, one small request from my side before I start this session, that our whole team has done a lot of effort to make this session possible. One small request from my side, guys. One small request from my side. Can you please like the session and share it with all your friends so that maximum students can get benefited? Everyone, please. Can you please share the session so that all the students can get benefited? Yes. Come on guys, please share the session. Okay. यार ये मेरे ही मोबाइल में डल लग रहा है वीडियो की डल ही है. पूरा ब्राइटनेस फुल कर लेना यार. प्लीज मेक द ब्राइटनेस कंप्लीट. ओके, गुड मॉर्निंग. कम ऑन. Good morning. Can you please like and share the session? And also one more thing, guys. Can you please write down your cities? Guys? So I can see that from which part of the country the students are watching me right now. Come on. चलो. ओके. भागलपुर, हैदराबाद, पटना, इम्फाल. ओके माय गॉड. इम्फाल इज कैपिटल ऑफ मणिपुर, है ना. बेगूसराय, विशाखापट्टनम आर के बीच. राजामुंड्री, आई गेस इट इज इन उद्यर ना, आंध्र प्रदेश और तेलंगाना. पटना, श्रीनगर. Okay, I've been to Srinagar many times, guys. My father was posted there. Yes, Vaibhav Negi, the MTech from Transport is here. Airport Authority. Cuttack, Bihar, Visakhapatnam, Tamil Nadu, Chennai, Bhubaneswar, Chennai, Nagpur, Bangalore. पूरा मैप हो गया यार. Okay. Complete map is here. Madurai, Trivandrum, Bangalore, Imphal. Manipur, our state is now burning. Why? Oh yeah, something new. I'm not very aware with the news, but I have seen something like this in the news. Kharagpur, Karnataka. Kharagpur, Souvik Jana from IIT Kharagpur you are? Okay, Lucknow, sir is from Lucknow. Okay. Let's start then. Okay, guys, Anantapur, Andhra Pradesh, Kharagpur. Okay, guys, one more thing I would like to tell you before we go forward, that in geometry design, we deal with visible features of the road, like what is the width, okay, and what is, if the road is in a curve, then curve we extra wide. We make the road little bit wider. Why on curve the road is a bit wider? Why it is extra widening? So in first chapter in geometry design, we are not dealing with traffic. If traffic is more or less, okay, we are dealing with visible features. That what should be the width? Okay, how much we should be able to see? Okay, that all things we will be seeing in the geometry design chapter. But in the second chapter, traffic engineering, we have nothing to do now. In this second chapter, we have nothing to do now with the dimensions of road. Okay, in the first chapter we deal with dimensions and not the traffic. In second chapter, guys, we have nothing to do with dimensions. Width is less or more, we don't care. Okay, here we are dealing with traffic volume, or traffic volume is what I'll tell you later on. Traffic, number of vehicles. Okay, in third and fourth chapter we are dealing with the pavement. Okay, all the road is on the bitumen road or the concrete road. What should be the thickness? How the thickness will be calculated? That we will be doing in this. Okay, so first chapter deals with dimensions of the road, not the traffic. Second chapter deals with the traffic of the road. Okay, number of vehicles of the road, not the dimensions. And these two chapters deal with not the traffic, okay, and the dimensions, but the dimensions of the pavement, thickness wise dimensions, not the width and length. Okay, so let us go with chapter number 1. Okay, you are pro. No, I am not pro, yaar. Okay, guys, and let me tell you guys, the most number of subject I ever taught in this field, okay, is not strength of materials, is not soil mechanics, is highway engineering. First most number of subject I ever taught in my life is highway engineering. Second number is, I guess, survey, and third will be soil and soil. Okay, because in offline, guys, in every year, if I say from 2011 to 2019, every year, guys, I am teaching highway and survey at least 15 to 20 times. Okay, so let's begin with geometry design of highway, and guys, everything you will be understanding. Okay, I have come up with the car as well. So that I can make you understand the things when required. Okay, so this car will be going like this. Okay, let's move then. See, in geometry design, we'll be dealing with all these things: cross-sectional elements, side distance, horizontal alignment detail, and vertical alignment detail. In cross-sectional elements, now we'll be dealing with what is camber, what is carriageway. Okay, what is carriageway? I'll tell you everything. What is building line? What is control line? Everything. Okay, in side distance, we'll be dealing with SSD. All I will derive, guys. Okay, and I'll derive in such a way that Khanna Jastu has not also derived in that way. In horizontal alignment, we'll be studying super elevation, we'll be studying extra widening, we'll be dealing with length of transition curve. Okay, in vertical alignment detail, we'll be dealing with summit curve, okay, and valley curve, also called as sag curve. Okay, so these are the 4 parts of the chapter 1. Out of these 4 parts, guys, see, this is the weightage I told you of whole highway. Now for the first chapter, we are dealing with these 4 things. And these are most important. Okay, 90% questions are coming from these 2 topics, either side distance or horizontal element detail. From these 2, only 10% topics are coming. Okay, so guys, when I will be completing the chapter 1, then I'll again come back here, that have you understood all the things or not. Okay, in between you can ask me a doubt as well, guys. I'll be more than happy to take care of your doubts as well. Okay, come on everybody. ओके, चलो इससे आगे चलें भाई लोग. चलो, the important surface characteristic, the vehicle is moving on the road na. Where is the vehicle? This vehicle is moving on the road na. So guys, in the first chapter we have nothing to do with vehicle. हटाओ इसको. Okay, in the first chapter we have nothing to do with the vehicle. We have to do with this characteristic. Okay, so the characteristics are friction. What is friction? I'll tell you. Unevenness, light reflecting characteristics, and drainage. Okay, all these will be go one by one. Let us go with the friction. Now guys, everyone, please see one thing, that it is one of the factors determining the operating speed and minimum distance requirement. Let me tell you why friction is important. Guys, of course, everything in this universe is having a friction, maybe less or more, but everyone is having a friction. Guys, see, even the Alia Bhatt cheeks will also be having a friction. Might be she is using so many cream ponds, there will be friction. Might be my skin will be more friction. मेरे स्किन में तो इतना फ्रिक्शन है, कोई ऐसा हाथ लगाएगा तो हाथ में चीरा पड़ जाएगा भाई. Okay, so everybody is having friction, and why that friction is due to when we see the road from microscope, then road never will be like this. When we see the road from the microscope, of course the road will be like this from microscope. Okay, so due to this, it is not smooth, or it will be providing the friction. Okay, now because what if friction is not there? What if the road is very smooth? There will be case of slip. What is slip? Slip is that, guys, normal case. Let me tell you here, first of all, normal case. Guys, in normal case, if the vehicle tire is here, the diameter of the tire is D, and suppose this tire reaches here, okay, diameter is D, 1 rotation. So what will be the longitudinal distance? 1 rotation. What will be the longitudinal distance in normal case when there is no slip? When there is no slip, guys, this is moving 1 complete rotation. Okay, this is moving complete 360 degree. This is moving complete 360 degree. So when this is moving complete 360 degree, suppose this, see, my hand is at the top, again it comes here at the top, then how much distance it is moving this vehicle in normal case? Tell me. Rahul Kumar, duration का मतलब ही नहीं है. We have to complete highway. Okay, whether it take how many minutes? It comes off highway, transportation total comes of 10 marks, out of which highway is 90%, that is 7 to 8 marks. Okay, now longer distance will be 2 pi r, or we can say pi d. This is the normal case. Normal case. Okay, in normal case it is like this. The movement will be pi d. Pi d. Okay, what is slip? What is slip? In one rotation, see here, in one rotation, it has done many rotation, but it is only approximately here at the same position. The longitudinal distance cover is less than pi d. Understood? Guys, when there is slip, when there is slip, it is slipping like this, but it is not moving much ahead. Tires are moving like this, but it is not moving much ahead. So longitudinal distance will be less than pi d. Correct? Correct. Give me yes or no in the comment box, guys. Thomas, Pooja, Gijresh, Kumar, everyone. And this is the case of slip. Okay, and this is due to lack of friction. If friction is there, it will not slipping like this. Then one more case of skid. Okay, you have seen the tire marks like this. Okay, in skid case, guys, one rotation, guys, in skidding now, vehicle is moving ahead, but tires are not moving much. So up to the tire rotates one complete, vehicle has moved very far ahead. So here the longitudinal distance is greater than pi d. Everybody on the comment section, give me yes or no. Everybody on the comment section, guys, give me yes or no, guys. Keep sharing the session, guys. Okay, tell me, come on. Everybody understood? Okay, this is the skid. In skid, guys, vehicle is moving more and tires are not rotating much. Okay, so movement is more and this is less. Now, factors affecting the skid resistance are the conditions of pavement, either they are wet or dry, tire condition, speed of vehicle, brake application, and load and tire pressure. Now, according to IRC, guys, there are two types of friction. Now listen to me. What is stopping side distance? We'll see later on. Suppose this is a vehicle and this vehicle is moving like this. Guys, just after 2 minutes, I will tell you a concept that is wrong written in books, Khanna Jastu, and you also thinking it wrong. I will ask you the question, you will all answer it wrong. Okay, in Khanna Jastu also it is written wrong, and why it is even wrong then we are adopting in highway, that also I will telling you. Okay, just in 2 minutes. Okay, Asnar, Amsa, PK, Thompson, everybody. Okay, when vehicle is moving here then guys, when vehicle is moving ahead, tell me where friction will be acting. Longitudinal friction. Where longitudinal friction will be acting? Everybody on the comment box. Tell me please. Everyone. Please. Tell me. Friction will be acting where? Friction will be acting here, means this is forward direction, this is the backward direction. If vehicle is moving here with velocity v, then vehicle is moving, friction will be acting forward or backward? Tell me. Tell me, guys, come on, yaar. Only one person, Kumar, Anish, Kshitij. Come on. Tell me, guys. Come on, make it interactive, yaar. Okay, now very good. Couple of people's, I haven't seen the name, Kodari and Alikya. Good. Guys, friction will also be forward only. but still this is my question, guys. Actually, I was supposed to ask that question just after 2 seconds. I intentionally waited 2 minutes because otherwise because after 2 minutes you will be very attentive, na? After 2 minutes you will be very attentive, na? That sir will be asking a question. So where we will be answering wrong, so we should answer reverse. That is why not 2 minutes I instantly asked the question. So guys, here when vehicle is moving forward, na, friction is also acting forward. Guys, friction acts opposite to the motion. Yes, I'm still saying that opposite to the motion. But see guys, everyone, friction and opposite to the motion. But when vehicle is moving forward, okay, when vehicle is moving forward, then tire with respect to this pavement, this is the road, then tire is moving where? Tire is moving where with respect to road? Backward, na? When vehicle is moving forward, this is the forward direction. When vehicle is moving forward, the tire is moving backward, na? Okay, the tire is moving backward, na? When vehicle is moving forward, the tire is moving backward, na? Okay, then friction acts opposite to the motion. So the motion is backward of tire because tire is touching with the ground, na? Tire is only the thing that is touching with the ground, na? Okay guys, come on, see. If this is a vehicle, this is the tire. When vehicle is moving forward, the tires are going backward, na? Tires are rotating backward, na? So what is the motion of tire? Backward. So where friction acts? Opposite to the motion. So motion of tire is backward. So friction will be acting. This is the velocity and this is the friction also acting. Okay. But in highway, in derivation, we always see that friction is acting backward. Why? Why in Khanna Just 2? Why in this Khanna Just 2 book friction is backward saying? Why? Because guys, we study the friction in the case of braking and in the case of braking vehicle's tire does not rotate. In the case of braking, tire does not rotate, tire skids. Okay, without rotate, see the front tire, it skids like this, in case of braking. So where tire is moving with respect to ground? Where tire is moving with respect to ground? Tire is moving forward now. Okay, but when it is rotating, it is moving backward. When it is skidding, braking case, tire is moving forward now, forward. So friction will be acting backward. So we study the friction. Okay, in case of braking. That is why in case of braking, tires are not rotating. If they are not rotating, they are skidding forward. So friction will be acting backward. Okay, and this friction is called as longitudinal friction. This friction is called as longitudinal friction, which is given 0.35 to 0.4. It will be given in the question. As per IRC, now you need not to learn the table. There is different velocities written, and with different velocities, mu longitudinal is written 0.35, 0.36, 0.37, like this. But for different velocities, different mu longitudinal is given. Now let me tell you one more thing that nobody has told you. In that case, na, if you see that table, guys, with increasing velocity, na, if you see that table, na, with increasing velocity, suppose here it is 60, here it is 70, here it is 80. So mu is actually decreasing. It is 0.4 here, 0.39 here, 0.37 here, like this. I am not remembering, but I am telling you the logic that when velocity is for more, mu is less. Can you tell me the answer? Can you tell me why it is so? Because GATE will never be asking a database question. Na? They will never ask that what is the value for mu for v is equal to 70, what is the value of mu for v is equal to 80, what is the value for mu for v is equal to 65. They will never be asking this. But yes, they can ask that according to IRC, if velocity is more, why mu is decreasing? The reason being, go to the back when I was starting the friction. Friction is due to the unevenness. Okay, friction is due to unevenness. And guys, when vehicle moving, there is interlocking of tire and these unevenness. Okay, as there is more interlocking of tire and the road, then it is more friction. Guys, when speed of the vehicle will be more, when the speed of the vehicle will be more, swing, then the interlocking between the tire and the road will be less, na? And when vehicle is moving slow, interlocking hoga. Interlocking between the tire and the unevenness of road will be there. When vehicle is moving fast, interlocking will be less. That is why when velocity is more, mu is less. Everybody on the comment section, please put a heart sign if you understood this. Everybody on the comment section, guys, please put a heart sign if you have understood this, guys. Come on. Come on. Everyone. Hit it, hit it, hit it. Everyone. Come on. Tell me. Tell me. Put a heart sign, put a heart sign. Yes, yes, yes. Thank you all. Now, guys, there are two types of mu. One is mu longitudinal and one is perpendicular. Mu longitudinal is in the direction, or it is having the same direction of the vehicle movement. Okay, it is having the same direction of vehicle movement. And in this direction, there is mu lateral. Mu lateral value of code, IRC is our code, Indian Road Congress, is 0.715. That is fixed. Mu longitudinal is changing. Mu longitudinal is changing, but mu lateral is same, that is 0.15. Okay, now where mu, sir, I understood, sir, mu longitudinal will be coming in the term in when the braking is there, but when mu lateral will be coming, when mu lateral will be coming, let me tell you guys, when the road is curved, guys, this road is not flyover, this road is not flyover, this road is a curve in single plane, means elevation of A point, elevation of B point, both are same. This is not a flyover. This is actually the road is moving like this in a same plane. Okay. Now when vehicle is moving or negotiating in a horizontal curve, then centrifugal force acts on it. Centrifugal force acts on it, that is mv square by r. Centrifugal force acts on it, mv square by r. Now who will, if there is no friction, okay, then this mv square by r may be toppling the vehicle, or this may go here. The vehicle may go off track. Okay, so vehicle doesn't go off track, vehicle doesn't go off track, or vehicle doesn't topple, the friction is opposing, friction is resisting it in this direction, that will be mu lateral, 0.15. Everybody give me yes or no. Have you understood? Have you understood? Please put us heart sign. Okay, okay, great, great, great. Okay, this is all about friction, guys. Now unevenness index. Unevenness index is, we want to know that is the vehicle is the traffic, is the road is almost smooth. Actually no vehicle will be, no road will be almost smooth, or the road is like this, uneven. Okay, if the road is like this or road is like this, uneven. So this we found out by assembly, and that assembly is bump indicator. Okay, and that assembly bump indicator is not available in NITs, bump indicator is not available in IITs, bump indicator is not available in any research institute except CRRI, Central Road Research Institute, that is in Mathura Road. I have visited this CRRI. Okay, my friend is scientist there. Okay, that time in 2012 through the GATE score, they have recruited the scientists same like BARC. After that, there are various court case and other things. So sometimes they take with GATE, sometimes they take their own exams, sometimes they do with any other on the basis of college score, like this. So what is bump indicator, guys? We before, see, on duty of national NHAI, okay, we attach assembly like this. Okay, and now in this assembly now, let me tell you, like this. This is the vehicle. Okay, now with this vehicle we attach the bump indicator. This is bump indicator. Now in this bump indicator there is a needle. Okay, now guys, if road is plain, the movement of needle will be less. Okay, and if it is not visible, this is a vehicle. In this vehicle a bump indicator is there. This is bump indicator, needle is there. If road is plain, needle movement will be less. If road is like this, the needle movement will be more, and there is a sensor from which we can measure the needle movement. Now if the needle movement is less than 1500 mm, the total needle movement, total cumulative movement is less than 100 mm per kilometer, this is good. That will be called or characterized as a good road. 1500 to 2500 satisfactory, 2500 to 3500 bad, and greater than 3500 it is uncomfortable. Okay, now for drainage, guys, see what is camber. What is camber? Guys, see, everyone, suppose this is a road now, so road will never be made like this. This road will be made like this only by computer science engineers. Computer science engineers will be making like this road, or electronics or electrical. Okay, civil mechanical will never make road like this. They will make road like this, little bit slant. Okay, it is not as slant as you can play that क्या कहते हैं उसको slide. The kids play slide. It is not as slope as this, but a gentle slope, a mild slope will be there. Okay, and I'm not saying slope in the direction of movement of vehicle. I'm not saying slope in this direction. I'm showing the cross slope. Okay, in this direction. In this direction, the little bit slope will be in this direction, so that when the rain comes, water can drain off either here or water can drain off either here. That is called as camber. Okay, that is called as camber. Like road is not made like this. This kind of road will be made by a computer science or electronics engineer. Okay, civil people will be making road like this. Okay, one vertical in and horizontal. One vertical, this slope is one vertical in and horizontal. So if from here to here, now from here to here, okay, so if it is one vertical in n horizontal, so I can say n horizontal in one vertical. I can say one horizontal, for one horizontal movement n by v vertical, 1 by n vertical. For one horizontal it is 1 by n vertical. Now from here to here, what is the horizontal distance? W by 2. If W is the total weight, so from here to here, what is the horizontal distance? W by 2. So W by 2 horizontal, for one horizontal, 1 by n vertical. So W by 2 horizontal, it is W by 2n vertical. So this distance is W by 2n. So either we make this kind of camber, but this is not good. Can be done in village roads, where or not, where the not, I cannot say village roads, but the better term will be where the traffic is less. Okay, it's not okay. Villager की जिंदगी नहीं है क्या? Okay, so these kind of slope should be made where the traffic is less. Okay, so that water can drain off. But guys, when traffic is more, so every time the vehicle is moving from this point, when the vehicle is or when the traffic is more, so to overtake and all, vehicle will be passing from this point. This point is appointed, so there will be wear and tear of the tire. So in that case, the road is made like this. Okay, this is a parabolic camber, so that whenever the Indra Bhagwan aate hain, Indra Bhagwan, okay, the rain comes like this. Okay, so it can be drained off. Okay, the equation of this parabola is y is equal to 2x square and by nw, so that smooth transition is there. Okay, now of course we can use a combination of straight and parabolic so that here also the pointed at the mid is avoided. Now what is the camber? So that rain can be drained off. This is written like this as per IRC table. Like our code for RCC, it is IS 456 is to 2000 na? Similarly for highway the code is like this, and these are the values. Okay, see, earthen road drainage will be difficult, so camber is more. Earthen means of soil. Okay, the drainage will be difficult, so camber is more. When it is concrete road, in concrete easily the water can drain off. In concrete, the easily water can drain off. So you can see that in concrete, the drainage is less. In concrete, the drainage is less. Okay, Kumar, Ansh, Bharat, everyone understood? Guys, speed is fine or should I increase my speed? Speed is fine or should I increase? Tell me, yaar, come on, come on, come on. Everyone. And these all are written beautifully in and along with the other subjects in civil ki goli book. Okay, it is written beautifully there. All are presented in a chart and compiled up in a beautiful book. Okay. Now, guys, cross slope camber continued, and this is the width of carriageway. What is carriageway? What is carriageway? Carriageway is the bitumen road or the concrete road in which actually vehicle moves. Like this is the carriageway. This is carriageway. Okay, this all is carriageway. This all is carriageway. Okay, this is carriageway. This is carriageway where the vehicle is moving. This is carriageway. Okay, now guys, everyone, let me go further. Okay, median is this divider, you know. Okay, median is this divider. Okay, and plants are put on this so that in night the vehicle which is coming here and the vehicle which is going here, the headlight should not be disturbing the other driver. The headlight of this should not be disturbing this. So guys, the trees are also planted. Now what I was about to say to you is listen, this is the carriageway. Guys, why the name highway? Very important. Asked in UPSC, GATE, IIT professors in GATE and in some PSUs and state service examination. Why name highway? Can anyone tell me why the name is highway? Any specialty of this name? Okay, I'll adjust the speed. Kushal, Captain, Nandu, everyone. Why the name highway? Because guys, it is actually it is high plus way. Okay, it is high plus way. Let me tell you here. Why name highway? Because actually this way, the way for the traffic should be high. Okay, it should be more than the ground level. Highway, the way is at little bit higher than ground level. The reason being, if the rasta, if the way, if the carriageway, if the road is at the ground level, then when rain comes, so rain will be accumulated or runoff may be accumulated in the ground, may be possible. Okay, if there is not proper infiltration or there is a heavy rainfall, in that case guys, the rain or the water will be accumulated in the ground level. And if the ground level and highway, the carriageway are in the same level, then that water can come in the highway as well. So always guys, a engineer, a civil engineer, a transport engineer will be making the highway a little on elevation with the respect to ground level. Okay, that is why it is highway. Okay, so that in case of flooding, the water should not be coming on the road. Now let me tell you guys the cross-sectional details. This is the ground level. This is the ground level. See this highway of little bit height. Okay, and here is the carriageway. This is carriageway. In this vehicle will be, this brown is carriageway. In this vehicle will be moving. Okay, and this green is shoulder. Okay, so that is carriageway and this green is shoulder. Understood? Now what is shoulder? Carriageway is the road. This is the carriageway. What is shoulder? Shoulder is this soil guys. This soil na, where when you have a puncture, you park your vehicle here na. That is shoulder. Okay, this orange is the carriageway. Okay, and if you can want to show the median, if it is there, then you can show the median as also. This is the divider or median. That is the carriageway. This is the median. This white one is the median. This orange one is the carriageway where vehicle is moving. And this is the shoulder where when you want to or might be puncture, you will park here. Okay, that is of soil. Now here are some imaginary lines. Building line, and also here are the building line, and here are again some imaginary lines, control lines. Now guys, we have done the soil mechanics marathon already. Have you seen that Westergaard and Boisingh equation? Due to a point load or due to any load, there is a stress at z distance away and z distance below and r distance away. There is a stress at point P, sigma vertical at point B, kb into q by z square or kw into q by z square. Similarly guys, the NHI and the committee has said that near the highway building should not be constructed. Building should be constructed away from the control line. Here the building can be constructed. Here the building can be constructed. Okay, around 80 meter, 100 meter building should not be constructed because the highway, the pavement and the below layers are designed for carrying the load of the traffic. If some other heavy building is coming nearby, then because we always design this pavement on the basis of the load of the traffic. We never design the pavement on the basis of building load. So maybe the soil here is not failing due to the traffic, but that soil is failed due to the combined stress here due to traffic and due to building, and there should be a failure. Okay, because we should design only on the basis of traffic. We will not be taking the effect of buildings. So building should be little bit away so that here should not be failure of soil. Okay, because might be due to the load of traffic and building, here is a failure. So the building should be more away from the control line. And what is building line, guys? Whenever you are making the building line, you are making some other temporary structures also, temporary arrangement also. You will be putting the brick on the side, you will be putting the concrete on the side, you will be putting the steel on the side, so that construction materials can be put here. Okay, that construction materials can be put here, but inside the building line, even the no activity and no construction material should be put. So inside the control line, building should not be constructed, and inside the building line, any building activity should also not be done. Give me yes or no. This is the cross-sectional detail elements. Okay, give me yes or no. Everything I told you here. Now the cross-sectional element detail is done. I told you now the first chapter is of 4 parts. Where are these? So this is done. Now I am going to the side distance and then horizontal and then vertical. This will take more time. This will take just 15 to 20 minutes. Okay. Side distance element मजा आ जाएगा guys. ऐसा derivation कराऊंगा मजा आ जाएगा. You'll enjoy like anything, guys. You'll enjoy like anything. My guarantee to all of you. चले जल्दी बोलो. Shall we move forward? Everyone? Till here any doubt? Please tell me. No doubt na? करें आगे चलें? Shall we move forward? In between, if you found any doubt, you can ask me. Okay, Jaya, Kumar, Bharat, Ved, and everybody. Now see, English, don't read this English here. I'll provide this PDF. See me here. Don't study this English. Okay, guys, stopping side distances, I'll tell you very beautifully, guys. Very beautifully. Okay, now stopping side distances, I'll explain all these things. That it is the distance when vehicle requires to stop. But in how much distance the vehicle is stopping? Okay, guys, suppose this vehicle is coming from this position and masti se aa raha tha, very enjoying his driving, enjoying his journey, is coming, gaadi mein gaana laga hai, jadoo hai nacha hai. He's coming very enjoying the songs and the music, and suddenly he see, oh, there is obstruction, might be a child crossing the road, might be the Gau Mata, might be any tree falling. Or so from this position he see, oh my God, there is something. Okay, I should apply the brake. Then as soon as he see the obstruction, of course he is not Rajnikant. For some distance, that is lag distance. For some distance he will not apply the brake, because guys, he is not Rajnikant. As soon as he see the cow or see the tree falling or child crossing the road, he will apply the brake. No. So there will be some distance where he doesn't apply the brake, because of course it will take some simulation, it will take some time so that his brain works. And then he see, oh, I should apply the brake, and then he apply the brake, and then ultimately it stops. So the distance where he doesn't apply the brake, okay, because although if he knows that he has to apply the brake, of course he is not Rajnikant, it will take some reaction time. Okay, it will take some reaction time. So when he doesn't apply the brake, that distance is lag distance. Okay, and when he from this point he started applying the brake, and now this distance is braking distance. This distance is braking distance, and this total distance is stopping side distance. The distance required by the vehicle to stop. The total distance is the distance required by vehicle to stop. Now again the question is, why we are finding this, yaar? Why we are finding this? That at how much distance vehicle will stop, that is stopping side distance. But why we are finding this, yaar? What is the necessity? Why we are finding? Let me tell you. Guys, suppose this is a curve. This is a horizontal curve in a mountain. In a mountain you are going, there is a curve. Now, when there is a curve in the mountain and there is some building here, there is some building, there are some trees. Okay, now there are some building and there are some trees. Now tell me, guys, in this road, if a child is crossing the road here, or a tree is falling in the road, okay, a tree is falling in the road. Now here, if a vehicle is moving here, okay, if a vehicle is at this point, will he be able at A point, this is the A point, will he be able to see the tree? Tell me on the comment box. Will he be able to see the tree falling on the road from A point? From A point, will he be able to see the traffic? This? No, because the buildings will be coming in between. He will see, this is the A dash point. Now from the first time he will say, oh my God, the tree is falling. From A dash point, first time he will be seeing, oh, the tree is falling, I have to apply the brake, otherwise I will collide. Now from here to here, suppose the distance is 70 meters. So guys, that obstruction he has seen from 70 meters, because when he is here, he is not able to see the obstruction. The first point where we have seen the obstruction is from 70 meters. Correct? The first point where he sees the obstruction is 70 meters. Now guys, when he is seeing it at 70 meters, now his stopping side distance should be less than this. His stopping side distance should be less than 70 meters. 70 meters, I just given an example. Okay, stopping side distance should be less than 70 meters. If stopping side distance is more than 70 meters and he is seeing the tree first time at a distance of 70 meters, and then he is seeing that, oh, I have to apply the brake, and if his braking distance or his total distance at which he stops is more than 70 meters, he will collide with the tree. Okay, so this distance should be less than 70 meters, or vice versa I should say. Now listen to me guys. What is the necessity of stopping side distance? What is the necessity of stopping side distance? Listen to me. We will calculate stopping side distance. Listen. Stopping side distance will be different for different drivers. Might be Abhinav Negi is very slow. He will take a large distance to stop. Let me take a name of a student. Might be Bharat is very quick. He can stop early. So of course, for a design speed and some ideal conditions which I assume constant for all drivers, I will find the stopping side distance. Now whatever that value comes, when I will be designing the road, at every point, the distance visible to the driver, at every point, the distance visible to driver should be more than stopping side distance. I'm again saying whatever the stopping side distance is coming, stopping side distance will be different for different person. Of course, we'll be taking as ideal condition. Whatever that value is coming, I have to make the road that every point on the highway, the distance visible should be more. Okay, that distance visible 70 meter should be more than stopping side distance. Then only there is no collision. So distance I am seeing will be more. The distance seen by the driver should be more, and the stopping side distance should be less. So that whenever he see a obstruction, child crossing the road or Gau Mata or the tree falling, his stopping distance should be less, so he can stop before colliding with that. Everybody on the comment box, give me yes or no. Have you understood the meaning? Have you understood that every point our distance visible to the driver should be more than the stopping side distance? I have to make the curve, I have to make the buildings, everything like this. Yes, so that is why we are calculating the stopping side distance. That is why we are calculating the stopping side distance. Okay, at every point the distance visible should be more. Okay, this red car should be visible from a large distance, so that clash should not be there. Okay, so distance visible or the obstruction should be more. Now from here he thinks he'll apply the brake. This distance he doesn't apply the brake, and then this distance he applies the brake. So total stopping side distance is lag distance plus braking distance. Now guys, in whole highway engineering na, whenever I am using small v, then it is in SI unit, meter per second, and I will write all my formulas for SI unit only, meter per second, meters and all. And whenever I will write capital V, this will be in some empirical formulas, capital V is also there, so that will be in kilometer per hour. So what is the lag distance? What is the lag distance? Lag distance, in here he has not applied the brake now, moving with a constant speed v, so v into t. Now this t will be different for Abhinav Negi. Might be I am having a slow reaction, might be Bharat, Akela, Pooja will be having a high reaction. Okay, so this t should be taken by 2.5 seconds. Now many of you doesn't know this, that is why now you are not knowing the minuteness of the things. From where this 2.5 second come? The reaction time t is 2.2 seconds. Can any commando can tell me from where this come? Why the code has taken 2.5 seconds? Why not 2.4? Why not 2.6? Why he has taken 2.5 seconds? Can anybody tell me? Can anybody tell me? Come on. Why 2.5? From PIV theory. From PIV theory 2.5 doesn't come. From PIV theory 2. Yes, Das, excellent here. Only one student. Debarta Das, where do you live? PIV theory is something different, that our brain will come simulate he will get the senses that there is some obstruction, then it will decide should we apply the brake or not, then he will give the decision. That is PIV theory. Okay, that is not giving 2.5 seconds, that is giving that why there is a lag. PIV theory is saying that why there is a lag. It is not telling you that why lag is only 2.5 seconds. Okay, so this 2.5 seconds, excellent here. 90 percentile reaction time. Guys, we have done an experiment on thousands of the driver. Okay, somebody takes the reaction time as 2.7 seconds, somebody 2.68, somebody 2.61, somebody 2.5, somebody 2.4, somebody 2.3, 1.6, 0.5. Some Rajnikant is also there. They are taking 0.001 reaction time. So the data which we collect, 90 percentile we have taken. Okay, the reaction time of 90% of drivers will be lesser than that. Okay, the reaction time of 90% of drivers will be lesser than that. From here we take 2.5. Now braking distance. Lag distance is VT. Now braking distance, guys, let me tell you the wrong derivation that is in the books and that you have done. Wrong derivation that is in Khanna Just 2 also. Wrong derivation. Let me check. Khanna Just 2 in this new edition, has he updated? Let me check. Wrong. Earlier it was wrong. I've written mail to him also. I've written the mail to him. Okay. Braking distance, how he had calculated. Okay, still wrong. Page number 94 in my edition. Still wrong. It is still wrong. Okay. Now see, what is the wrong? I will tell you. They say that change in kinetic energy is work done. Okay, the vehicle is like this. Okay, N normal reaction, mg downward. Guys, where friction is acting? Friction is acting in the forward, but in braking case, friction is acting backward. Mu into N. Okay, that is mu N to mg. Okay, so change in kinetic energy is, it is half mv square here, and at the end when it stops it will be 0. So half mv square minus 0, and work done is force into distance. So force is mu mg into distance is L. So L is equal to v square by 2 mu g. Then they say this value as v square by 2 mu g. Although numerically it is correct, but it is wrong derivation, and everybody in India is doing this only. In my offline also I teach this. I tell this to Khanadastu also over mail. That is absolutely wrong derivation. Let me tell you the correct derivation. Guys, change in kinetic energy is work done. Change is final minus initial. So final kinetic energy is 0 and initial kinetic energy is half mv square. Work done is not force into distance. Work done is F dot D. F into distance into cos theta. Work done is not force into distance. Work done is F dot D. Now mg and distance is here. So cos theta is 90. So that will be 0 work done. Normal reaction, force, distance is here, angle is 90. 0. Like Cooley is also, we say work done is 0 because mg is here, he is moving forward. But you should pay him. So guys, the work done is 0. Now work done is 0, but due to mu mg it is force F dot dl, and what is cos 180, because distance is here and friction is here, so angle is 180. Cos 180 is minus 1 to minus 1 cancel. From here the L is equal to v square by 2 mu g. Okay, this is the correct formula, v square by 2 mu g. Now one very important twist. See, SSD, guys, I am writing in small letters means, then my V is in meter per second. Okay. Now, guys, I want to ask this. Whenever I take interviews in BYJU'S, then also I ask this. Guys, if I take acceleration of a vehicle, maybe minus 2 meter per second square, and acceleration of a vehicle when apply brake is 4 meter per second square. Negative acceleration, retardation. One retardation is 2 and another vehicle is 4. Who will stop first? This will stop first. Who has retardation more? If both are traveling with the same velocity, this will stop first. His braking distance should be less. His stopping side distance should be less because retardation is more. But in this term, A is not coming, yeah? A not coming. How A not coming? Because when A is minus 4 and A is minus 2, one vehicle retardation is 2, one vehicle retardation is 4. So of course the 4 will stop first. So if all are having same other values, velocity, mu and all, so 4 will be having lesser stopping distance, but here A is not coming. Guys, here A is coming because the net force is mass into acceleration, na? So this net force is mass into acceleration. So A is equal to minus mu g. Okay, so in this mu term, A is also there. Okay, And guys, see, when I told you that this is a road and this is a tree and this is a vehicle, okay, so when building is here, when vehicle is here, he is not able to see the tree. But if the person is very tall, might be taller than Qutub Minar, then he can see the tree, na? We are seeing that he cannot see the tree because building is coming in between. But if the person sitting here, the roof of the this is also open, roof of the car is also open, and the person is very tall like Qutub Minar, then if the person is very tall and there is no roof, open jeep, then he can see the tree, na? So of course all these things that it can see or not see depends on the height of driver and height of object. So all these things are for 1.2 meter the eye level of the driver and 0.15 meter of the object. Okay, give me yes or no everyone. Give me yes or no everyone, come on. Then we are going further. So all these this is all on PIV theory. This is the SSD. Okay, now that thing, guys, SSD is equal to Vt plus V square by 2 mu g in plane road. But when there is an inclined road, then SSD is V square by 2g mu plus minus 0.01 n, when n is the gradient. Okay, like 3% n will be 3, like 4% n will be 4. Okay, n is the gradient, and of course when vehicle is traveling up gradient, then when vehicle is moving up, then it will stop early, na? So value should be smaller, then we should be using plus sign. When vehicle is going down, it will take more time, more distance to stop. So in down gradient, it should be minus. Okay. Now guys, see, if this, in this case SSD is SSD only. Okay, there are two lane, one way, both are moving. This has nothing to do with this. SSD will be SSD only. Okay, two lane, two way. One vehicle is like this, one vehicle is like this. This has nothing to do with this. So SSD will be SSD only. SSD will be SSD only. SSD will be SSD only. But when one lane, in one lane guys, one lane width is 3.75 meter. For multi-lane it is 3.5 into number of lanes. Okay, for multi-lane it is 3.5 into number of lanes. But for one lane it is 3.75 meter. For multi-lane it is 3.5 into number of lanes. When one lane, two way. In one lane both the vehicles are coming here. So what is the distance between them? Because SSD it will take time to stop. SSD it will take time to stop. The distance should be 2 SSD. The distance which should be 2 SSD. Give me yes or no. Give me yes or no. Everyone, come on. Come on, yaar. मियाँ 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 भाई, मियाँ 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 भाई, अपन को कहते मियाँ भाई. जल्दी बोलो. Any doubt? Any doubt? Please share the session guys so that all students can join. My humble request to all of you. Let me again share. Let me again share. Chalo. Share the session guys. Everyone. No doubt, sir. Notes I'll provide, na? Notes I'll provide. Why to waste time? Do this question. Here it is looking very dull. You do this question. Insert slide master, view. Slide master. I have to delete this. Fill, not fill. Color I want to change. Yes. Do this. Okay, the safe stopping side distance for a single lane two-way village road with design speed of 40 km per hour. Reaction time if not given, you have to take 2.5, but now it is given as 2 second. Coefficient of friction is 0.4. Guys, in SSD formula that Vt for plain road, it is V square by 2 mu g. Tell me, this mu is mu longitudinal or lateral? Okay, lateral is coming due to counteracting the centrifugal force. Okay, so here when it is going like this, okay, when it is going like this, so mu will be longitudinal. This is in the longitudinal direction. Okay, so that will be the longitudinal. Okay, and coefficient of linear friction over a descending gradient of 4%. Oh my god, gradient is also there. The safe stopping right distance of a single lane two-way village road with design speed of 40 km per hour. Guys, tell me in the meter per second. Tell me in meter per second value, please, somebody on the comment section. Tell me, someone. 4% gradient. N is 4%. N is 4%. Okay, so in this case the formula is V square 2g mu plus minus 0.01 n. Okay, one vehicle is going like this and one blue vehicle is coming down. Have you find meter per second? 11.121148. Everybody has different answer, yaar. Why so? Everyone has different answer. Tell me, yaar. Alekia, tell me. Pooja is saying 11.11. Now, what the distance between them is SSD of this green. Okay, SSD of green will be less, and of course it is going down, so of blue it will be more. So answer will be SSD of this green plus SSD of this blue. What is SSD of green? Vt 11.11 into reaction time is 2.7 Vt plus V square 11.11 V square by 2g 2 into 9.81 into mu is 0.4, and for upward the value should be plus 0.01 into 4. Okay, this is SSD of the upward plus SSD of blue Vt 11.11 into 2.7 plus V square by 2 into 2g mu minus 0.01 into 4. Okay, 0.01 into 4. This is into 4. This is SSD of blue. What is the answer coming? Commanders, play! Got it? Got it, everyone? Please tell me. Please tell me, everyone. चलो बता दो भाई, बता दो. साइड हो जाऊं? साइड हो जाऊं? अब सही है? Okay, you have done this only, na? You have done this only, na? Now do a MSQ. MSQ को फोड़ो. क्या कह रहा है? Which of the following statement are correct regarding the safe stopping side distance for design speed is assuming coefficient mu is this, reaction time is this, G is this. Safe stopping distance of two-way traffic, two-lane road. Okay, two-way traffic on a single-lane road. Safe stopping distance two-way traffic. इसको बाद में देखेंगे two-way को. सबसे पहले तो सिंपल SSD बताओ. Tell me the normal SSD. What is V? What is V? कहाँ गया velocity? 50 km per hour. So 50 into 5 by 18. Somebody call it 0.278 or whatever yaar. Into 2.5 plus 50 into 5 by 18 का square upon 2 into mu 0.37 into 9.81. Tell me the value of this first. Tell me the value of this. 44.34. नहीं यार 80 कुछ आएगा ना यार, तभी तो ऑप्शन में 80 160 लिख रहा है. अच्छा पुराने वाले क्या बता रहे होंगे? 80. Keep sharing, keep sharing, keep sharing, and like the session, guys. In my mobile it is, my laptop it is only 15 likes. Come on, like it. $60. Let us take 60 meter. 80 आना चाहिए ना? हाँ? Because it is 80 and 160 coming. V is, have we taken right? 50 into 5 by 18 into 2.5. ठीक है. V square by 2 mu G. Tell. It is 50 coming. 61.3. So then none of them are correct. Then none of them are correct. Which of the following statements are correct regarding the safe stopping distance or design speed of 50? Assuming coefficient and reaction time of the driver is 2.9 G is okay. So leave. Then take this as 61. Take this as 61 meter. Take this as 122 meter. Now solve. Tell me. Safe stopping side distance for a two-way traffic on a two-lane road. Okay, two-lane road and two-way. So two-lane means one vehicle is going here, one vehicle is going here. So of course nothing has to be done. Fine. Safe stopping distance of two-way traffic on a single-lane road. In single lane, two-way. So in that case it should be 122, not 61. Safe stopping distance for a two-way traffic on a two-lane road. We already done. On a two-way traffic on a single, 122. So A and D. Understood? 60 पे 80 आ रहा है. Okay, we have changed the option only. We have changed the option only. Okay, good. MVS पूरा जुगाड़ लगा के रखते हैं. Okay. Okay. Now. Guys, don't worry, the first chapter will be taking almost half time of the marathon, and in first chapter only these things will take more time. Okay, now overtaking side distance. Okay, what is overtaking side distance? We are coming on that. Everyone. Okay, we are coming on that as well. Highway और चौदह से वो टेढ़ा दिख रहा है. ये टेढ़ा क्या दिख रहा है? अच्छा ये वाला चीज, ये टेढ़ा दिख रहा है. ये टेढ़ा दिख रहा है ना, ड्यू टू द कैमरा एंगल. ओके, We'll correct it later on. Concepts are important, not that. Correct? Okay. Chalo. Sir, hi sir, first time I see you in highway since when I was in grade of paid batch. Okay, Sandbook. Sandbook, I just told him that I teach most number of times, I teach highway only. Okay, even more than more than soil. But yes, that was in, after online I didn't teach much. But before that I was teacher of highway and survey only majorly. See. Guys, overtaking side distance. Let me delete this. I'll make my own diagram. I'll make my own diagram, है ना? See, what is overtaking side distance? I'll tell you. This is the distance required by a vehicle to overtake a slow moving vehicle. Okay. It is the distance required by the vehicle to overtake a slow moving vehicle easily. So it is not colliding with the vehicle coming from other side. Okay, so clear distance. How much clear distance should be there? Now, suppose a vehicle is here A. This is A vehicle. Okay, it is moving behind B vehicle. B is moving very slow. B is moving very slow. That is why A wants to overtake. So first guys, for some time A moves behind him only. Should I overtake? Should I not overtake? Okay, should I overtake? Should I not overtake? Should I overtake? Not overtake? Confusion. And it comes to the second position. Overtake, not overtake, overtake, not overtake. It comes to second position. Guys, in total marathon it will not take much time. Stay connected. Okay, those who have seen my marathons earlier also, first chapter of every SOM, that phase diagram in paid course also, in YouTube also, it will take more time. First chapter of SOM also take more time. It will take almost 40% of the marathon. Highway marathon will be much lesser than the soil marathon. Syllabus is less. So don't worry. Initially it will take more time. So A wants to overtake B. It is moving behind. Should I overtake? Should I not overtake? Should I overtake? Should I not overtake? The next cycling position, let me overtake. Let me accelerate and overtake. Okay, why he had decided from the second position? Because he has seen the C vehicle is very far away. At second, when he reaches here, C is very far away, I can overtake. So what he do? Apply on the acceleration. Of course, in one lane only one vehicle will be coming. So he has to switch his lane. So he will come here. A final position of A. And B will be moving very slow, it will reach here. B3 at third position, and C should be reaching here. Guys, now this clear distance from the initial, to the C is overtaking side distance. If this distance is there, we can overtake. If not there, we will not overtake. In that case, what to do, I'll tell you. So a clear distance from the first position to C should be this. If this is the distance, they should overtake. Guys, if more than this, it is very fine. If C is here, if C is even behind this or behind this, then it's more fine here. It's perfectly fine. Okay, at most, when C is coming here, when A is here, C should be here, not here. Otherwise, it will collide. Okay, let me widen up the frame, then you will understand. Okay, guys, I am saying when A1 is here, then C should be here. If it is here, it is very good, yeah, very good. At most, C should be here. If it is behind that, it's fine. So at least overtaking side distance should be this much. If C is the side distance even more, it's very good. Maximum to maximum, worst condition, when it is here, it should be here. The C vehicle should be here. It should not be here. Otherwise, if when it is here, it means they have collided. So at most C should be here. It should not be nearer than this. Understood? Understood? Okay. Now, this is the distance d1. d1 is the distance when A vehicle moves behind B. So what is d1? What is d1? In d1 distance, he is not overtaking, he is just moving behind it. So velocity into time. Reaction time here is taken by code is 2 seconds. Why 2 seconds? I'll tell you later on. Now what is the velocity here, guys? It is velocity of B vehicle. Velocity of B vehicle. When it is moving behind B vehicle, so it has to move with velocity of B vehicle only. Because if velocity is more, it will hit. So it is not accelerating this time, moving behind vehicle. When you are overtaking, so for some distance you move with the velocity of that vehicle only, na? So A is moving with velocity of B. Then only there is a clear distance, constant distance between them. Okay, and every time as per highway, the distance between them should be S. The distance between the two vehicles should be S. ऐसा नहीं कि from the bonnet of one car, the bumper of other car is kissing. Okay, back to back. No, there should be distance. And S should be equal to, in meters, 0.7 VB in meter per second plus 6. 6 is the length of vehicle. This should be the clear distance. So d1 is the distance when it is moving behind the speed of B vehicle only, that is VB into T, T is 2.2 seconds. Now d2 is this acceleration path. d2 is this. d2 is this. Okay, so d2, what is distance? ut plus half at square. So VB into T, now that T is actually different. VB into T, this T is accelerating time. ut plus half at square. Okay, and this is the d2 from the drishtikon, from A point of view. From B point of view, guys, same thing I can write down. This is S, this is S. 2S plus what is the distance traveled by B vehicle? B will not be accelerating, na? We don't want to overtake. So this is VB into T. Understood? This is the distance with respect to A vehicle, ut plus half at square, because it is accelerating. Now distance of B vehicle will be VB into T, and this is 2S. Both are same. Both are same. From here VBT cancel. The acceleration time is given by 4S by A. Now you put time this here or here, you find d2. Either you put here, you find d2. Now what is d3? In the same time, how much C vehicle is moving? d3 is V into T, velocity of C vehicle into time, overtaking time. Because A2 to A3. So C2 to time, this is the time 2 to time 3. Time 2 to time 3, it is T. After this position, he has seen that C vehicle is very far. After second position, he has seen C2. He is very far, we can overtake. So D3 is V into T. If nothing is given, this V should be the design speed. We assume, unless the speed of any vehicle is giving, that is moving with design speed. So OSD is D1 plus D2 plus D3. OSD is D1 plus D2 plus D3. Give me yes or no. Guys, if only one-way traffic, then D3 is not there. Vehicle from other side is not there. So one-way traffic, OSD is only D1 plus D2. And in OSD effect, no gradient effect. In OSD, gradient effect is not taken. Even if, okay, there is a one vehicle is going like this, one vehicle is coming like this. Gradient effect is not taken in OSD, because in D1 and D2 you will take plus effect, D3 you will take minus effect. It is almost same, we neglect this. Okay, so this is the OSD, and in one-way traffic, the C vehicle is not existing here. So OSD is D1 plus D2. Give me yes or no, everybody on the comment section. What coding? What is coding? What is coding, guys? I'm not understanding what you want to say. I'm not getting what you want to say. I'm not getting what you want to say. Okay. Enjoying, guys? Please put a heart sign on the comment section. Vansh, Bharat, Jaya, Pooja. everyone, chalo, enjoying. Now guys, if overtaking side distance is not provided, then we'll provide some zones. Okay, this is the overtaking zone. We put a signboard S1 that overtaking zone is ahead, be ready. Overtaking zone is ahead, and we provide here the vehicle should not overtake from this position also, because now the zone is about to end. So we provide here overtaking zone is end now. Similarly, vehicle is coming here, we provide a signboard that overtaking zone is ahead. And when the vehicle is reaching here, we don't want that it should accelerate from here. So at this point we say overtaking zone end. Okay, so when we are not providing OSD, we'll do like this. What is ISD? ISD has no physical meaning. It is 2 times of SSD. Now let me see, this is OSD, ISD, SSD. Guys, I'm asking you all one very important thing. I'm asking you all. What is more important for you? Gate or food? Gate or food? Tell me guys, what is more important for you, gate or food? Gate or food? Gate, Bharat ready. Somebody kill me, yaar. Somebody kill me. Guys, this is, I'm seeing from last 8 to 10 years in my offline that unfortunately in India, due to might be little bit responsible teachers also, parents also, people are thinking that for students the studies are the most important thing. I'm totally against it. As a teacher, I'm saying this. Guys, your health, your nature, your behavior, your respect towards elders is much more important than studies. Studies is even not in the first priority, second, third, fourth. I guess it will be after 7th or 8th priority. It is not the most important priority. Every one of you from last 2 years and for the next 2 years will be tensioned, stressed due to career. But career is a very small part of your life. Career will never be deciding that you are happy or not. Many engineering service officer, top gate rankers, students who are in PSUs are not that happy, and might be sometimes a student who is working for 20,000 rupees in a private company is very happy. So being happy is more important than gate yaar. Now here guys, which is more important? SSD, OSD, what is more important? SSD is top priority. Guys, SSD you don't have any choice. Like gate you have a choice, nahi clear hua. But food you don't have a choice, na. So SSD is top priority. You don't have any choice. You have to as a design engineer, you have to provide SSD, guys. Okay, in any case you have to provide SSD, because if you are not providing SSD, that means that when there is a tree, you will be colliding with that. When the child is crossing the road, you will be colliding with that. Okay, in any case guys, you have to provide the SSD. Okay, SSD has to be provided. There is no condition, no provision. You have to provide, otherwise there is a provision. OSD has a provision. Overtaking side distance is not there, na. Okay, then you put a signboard, overtaking not allowed. You put a signboard there, overtaking not allowed. Okay, Shashank, thank you, Shashank, thank you. Okay, please share, Shashank, please don't spam. Okay, so SSD has to be provided. There is no choice. You cannot say SSD not allowed. Okay, you cannot put a signboard, bacha crossing the road not allowed. You cannot put a signboard, a tree falling below is not allowed. Tree falling below is not allowed. You cannot say tree can anytime fall and your distance should be more. Your distance that you are seeing should be more. Yes or no, my students? Yes or no, everybody? Okay, in any case you have to provide. You cannot say that tree falling below is not allowed. Anytime tree can fall, anytime breaking. OSD you can say is not allowed and you can provide overtaking zone. So guys, at least you have to provide SSD. If you are providing OSD, it's very fine. Otherwise you can provide ISD also, intermediate, because OSD is around 3 times of SSD. So you can provide ISD. ISD has no physical meaning. Okay, it is not like that, that if the load is coming of 1000 kilonewton, you don't make the beam for 1000 kilonewton, na? You provide a bigger this, na? You design for the bigger load, na? Similarly guys, when you are not able to provide SSD, you can provide ISD. Okay, and for SSD OSD calculation, this should be the height of driver and height of object when you are checking that it is visible or not, but because the distance whatever is visible or not depends on the height. Okay, like the same thing, na? If this is like this is tree here, you are seeing this, there is a building here, so from here the tree is not visible, but might be it is very height, open jeep, and his neck is very high, he can see the tree. So that whatever distance visible or not visible, that depends on height. So these are the values of height of driver and object. Okay, now guys, what are the 4 parts of the chapter? What are the 4 parts of the chapter? 2 are completed. More than 60% chapter is complete. More than 60% chapter is complete. This is complete. The building line, control line, camber, carriageway, shoulder, SSD, OSD, ISD calculated. This will take only 15 minutes. Okay, so almost 70% of chapter 1 is complete. And let me tell you, of whole highway marathon, 60% time will be taken in first chapter, and this it will take 30% time, and this will take only 10% time, because here there are very less conceptual things. Okay, shall we move to the horizontal curve now? Enjoying till now? Should I increase my speed more? Should I increase my speed? ओके, कोई गाना सुना दो यार. कीप शेयरिंग गाइस. गाना सुना रहे हो कोई? ओके, okay, let's go now to horizontal curve. See, whenever a vehicle is moving in horizontal curve, so suppose this is the curve and the center of this curve will be somewhere here. Center of this curve will be somewhere center of this curve will be somewhere here. Okay, and here the vehicle is moving in the curve. Okay, it is very easy to teach highway in smartboard. In offline I teach more than 70 times na, but there was not smartboard, there was the blackboard. Okay, so it is very difficult to teach. 300 students are sitting in the class, and it is little, because for the teachers like me who are not having a very good drawing na, so for them it is difficult to make the drawings. Okay, so whenever there is a center, so away from the center there is a centrifugal force. Away from the center there is a centrifugal force, and due to the centrifugal force the vehicle may off track, the vehicle may come here, or the vehicle may collapse. The vehicle can come off track or it can collapse. Okay, suppose this vehicle is moving in here. Twin, 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 twin. Twin, 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 twin. Twin, 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 twin. So here centrifugal force is acting away from the center. So this may either topple or it may be off track. Okay, either it is topple, it is to off road. Now we have to take care of this. Okay, that our vehicle, when it's going in a curve, it may topple or it may off track. Okay, so we are doctors now. Okay, we'll treat it. See here, this is, now see, suppose our curve is like this. This is a horizontal curve, guys. Our curve is like this. Okay, and this is the road. Now suppose this is our vehicle, it is going inside the road, and it is going inside the road like this, like a curve it is going. Okay, this I am seeing the back end of the vehicle I am seeing from the back. So it is going like this. So here is center, so centrifugal force will be acting like this. One will be mg, one will be mv square by r. Give me yes or no. One will be mg, one will be mv square by r. Okay, so here r1 is the reaction and this is r2 is the reaction by the load on the wheel, and this is at s distance, center of mass, because mv square will be assuming acting at center of mass is s distance, and this is the distance b. Okay, this is the distance v. Now the first condition is to avoid skid. What is skid? Like vehicle is like this, na, going like this. The vehicle is going like this, like this. So skid means it is not coming here. Overturning means it is like this, toppling. Skidding means it is going here in lateral direction. Due to mv square by r, it is going like this. And toppling means like this. Overturning means like this. Skidding means it is going off track. Okay. Now that force is mv square by r should be less. Mv square by is gunda, villain. Mv square by r is gunda. Okay. Mv square by r is gunda, it is villain. And we have to be safe from this villain. And who is saving us? This villain should be less. Who is saving us? This lateral friction, mu into n, mu into mg. Okay guys, here who is saving us? This is lateral, not longitudinal. Longitudinal is in this direction. Lateral friction, mu into n, n is mg. So the hero is mu. Mu is hero. So from here, m to m cancel, v square by gr should be less than mu. Okay, v square by gr they are calling as, okay, they are calling as p. P is, they are saying p as centrifugal force. So p by w is mv square by r by mg. So that is v square by gr. That is my value. And f they are calling as mu. So v square by gr should be less than mu. If this is the condition, there is no skidding. Okay, this is all. V square by gr is also called as centrifugal ratio. Centrifugal ratio is centrifugal force by weight. Mv square by centrifugal force by weight. So this is the centrifugal ratio. It should be less than mu to avoid skid. Now to avoid overturning. Overturning means it is overturning like this. Okay. So now to avoid the overturning, what will be the condition? We will see that. To avoid the overturning. So overturning, see, this is the way it will overturn about this moment, this point. Okay, if suppose I am a vehicle, so if somebody is putting me mv square by r there, I will be from my right leg, I will be overturn about my right leg na. I will overturn about my right leg na. If someone is applying force to me like this, I will overturn about my right leg. So the overturning moment is mv square by r into h. Okay, this is the overturning moment, and moment of r2 will be 0. Moment of r2 will be 0. R2 is passing from that point only, so moment of R2 will be 0. Okay, now because R2 is passing from that point only, stabilizing moment will be mg, that helping us, mg into b by 2. This is b, so movement mg into b by 2 is helping us, and R1 force will be 0 na. R1 force will be 0 na yaar. Guys, R1 force will be 0 na, because when I am verge of overturning, my this leg will go up na. My this leg will go up na, it is not touching the ground. Let me show you here. When it is overturning na, this is R2, this is R1. When it is overturning, this will not be touching in the ground na, only this will be touching the ground, this leg, R2. When it is overturned na, this leg will not be touching the ground. See, this is the ground, now both are touching the ground. When it is overturning na, only this will be touching the ground. Okay, this will not be touching the ground. Okay. Okay. So R1 will be 0. So from here m to m cancelled, v square by gr, that is centrifugal ratio, m to m cancelled, is less than b by 2h. Is less than b by 2h. So these two conditions are there for no slipping and no skidding and no overturning. Give me yes or no. Everybody on the comment section. Everybody on the comment section, please give me yes or no. Have you understood or not? Everyone, each and every commando, each and every commando. Tell me. Yes hoga. Because what I'm not getting you. O khade which dung khadke. Means, what does that means? What does this mean? Please tell me. Okay, now these are the conditions. Now guys, but these are the conditions, but we cannot rely on friction na, because all these things that P by W is less than F, P by W is less than this, but F value is 0.15. F is mu na, F they are representing as lateral friction. This value is 0.15. So how you are sure that P by W is less than 0.15? How you are so sure that P by W, okay, wrong, okay, P by W is less than 0.15? We are not sure. So we have to make one more. Here our hero is, here villain is mv square by r. This is the villain, which is providing skidding or overturning, and helping is friction. So we are now introducing one more hero, that is man-made hero. Friction is actually natural hero. Okay, now man-made hero, that is super elevation. Now what is super elevation? Where I should see. What is super elevation? That suppose now this vehicle is moving in a turn like this. Suppose this road is going like this now. So this is the center here. So from center there is some mv square by r acting here. So due to the high velocity of Grand Prix, this high velocity of this F1 race, this may due to this high velocity may collide or may overturn. So now what we do, we provide super elevation. This is super elevation. mv square was acting here na. Okay, there is a turn like this. Actually this road is a turn like this. Okay, so from here center mv square bar is acting like this. So now I make it tilt. So tilt, it will be mg sin theta here. So that mg sin theta is little bit counteracting mv square by r na. That mg sin theta is counteracting mv square by r na. mg sin theta is counteracting mv square by r na? Yes or no? Yes, mg sin theta is counteracting mv square by r. So this is how super elevation helps us. Okay, this is how super elevation helps us. Now let me this all I'll tell. Okay, guys, everything I teach you on a blank page, that will help you more. That will help you more. New slide. Let me teach you everything in a blank page. Okay, so how super elevation is helping, you understood that. Okay, now the road was like this, we have raised it, this is theta, and E is equal to super elevation, and super elevation is equal to tan theta. Why we have done this? Because the vehicle was traveling in a, suppose here is the center, it is traveling like this. Okay, road is going like this. So here is some mv square by r. Okay, sorry, not here na. Road is, let me show you the length of the road. It is like this. So enter is here, so mv square y is acting here. So our now mg sin theta will be like this. So we have raised the road, so it is helping us. Of course, friction is also there, mu mg. Friction is also helping us, mu into n, and tan theta is super elevation. Okay, like here there is center here, road is turning like this, so it has tilted like this, so that the mv square by r is little bit balanced by the weight component. Now the relation when we find the overturning equation, when we do the overturning equation, I am not going into the derivation, that value comes 1 minus mu tan theta. The value comes, see, of last 5 years also I am still remembering. E is equal to super elevation, and super elevation is tan theta. So the relation comes for overturning is the main criteria. For overturning, if you find the relation, okay guys, this was the relation when road is plane. This was the relation when road is plane. Okay, this was the relation when road is plane. Okay, now when road is inclined, the relation is this. Everything is in SI unit, unless mentioned, everything is in SI unit here, and mu is here 0.35 or 0.15. This mu is lateral friction. So this is the condition we got. Now listen to me. This is the actual formula for overturning. Now guys, 1 minus mu tan theta is approximately 1, because mu value is 0.15. Mu value is 0.15. Correct? The mu value is 0.15. And guys, we don't provide the super elevation like मौत का कुआं ना, death well. We don't provide much super elevation. Super elevation is also very less. Okay, so tan theta is also very less. Super elevation is around 2 degree, 3 degree, 4 degree, 5 degree. Super elevation is also very less. Okay, mu is also very less. So this we take at 1. Although one question has been asked in previous year, in the previous year where the question was where the theta is very high. Okay, it was the theta of the Grand Prix. Okay, here the theta is very high, guys. In this theta is here, we cannot neglect. So that question was also the Formula 1 race, the Grand Prix road. So there we can't neglect the theta. There also we can't neglect the theta because theta was decent there. Okay, theta was decent there. So there we should not be neglecting this. Okay, so if we neglect this, then mu is friction, theta, tan theta is E plus mu is equal to V square by GR. This is the formula. E is our friend, super elevation. Mu is our friend. Super elevation is helping us, mu is also helping us. These are friend. And this is our enemy. This is a mv square by r na. This is a part of mv square by r na. This is our enemy, which is overturning us or which is skidding us. And these are our friends, E plus mu. But this formula is only 1 minus mu theta is approximately taken as 1, which by default we take it as 1. But one time a question is asked of the F1 race. In that F1 race question, the theta was decent, like here. Here theta is not less. If theta is less than 7 degree, we can use this formula. Otherwise, we have to use this original formula. Okay. So E plus mu is equal to V square by GR. Now, guys, there is a equilibrium super elevation. Equilibrium super elevation means friction we are assuming to be 0. Okay. So if friction we are assuming, this is the formula na. If friction we assume to be 0, then whatever the E is coming, that is equilibrium super elevation. Okay. Now, third is designing super elevation. Guys, see, super elevation, providing super elevation is not easy because the formula is E plus mu is equal to V square by GR, SI unit. V is in SI unit here, meter per second. But every vehicle in the road has different velocities. Every vehicle in the road has different velocities, and for different velocities, different super elevation will be coming. For different velocities, different super elevation will be coming. Okay, and one more problem, that suppose this is our case. If high velocity vehicle is coming, it's fine. The theta is also more, it's fine. But if we provide high super elevation like in this case, and a bullock cart comes, now bullock cart speed is less, so mv square by r is less. Why? Because v square is less, velocity of bullock cart is less. But we have provided a large theta, so might be that vehicle is not toppling here, but that topple inside, opposite happens. Okay, so guys, might be, see, this is the vehicle. Suppose it is going like this. This vehicle is going like this. So this is the center. Okay, this is the center. This vehicle is going like this. This is mv square by r here. Mv square by r will be acting there. Mv square by r, because here is the center. Here it is moving in a horizontal road. Okay. So mv square by r is here. So to resist mv square by r, which is acting there, we make a super elevation. We make a super elevation like this. Now if mv square by r is less, but if we provide more super elevation, so it is not overturning there, because mv square by r is less. It is not overturning there, but due to high super elevation, it will topple here. Opposite can also happen na. I am again saying, if bullock cart is coming, velocity is less, mv square by r is less, so it is not toppling there. But due to high super elevation, it topple inside. This may happen na. So due to all these things, how we design the super elevation is, first step, take mu is equal to 0 and find E. And due to mixed traffic, not for velocity V, because if we design for velocity V, then for vehicles, slow moving vehicles, it can topple inside. So design for mixed traffic condition, 0.75 V. Guys, the maximum super elevation, so that vehicle should not topple inside, the maximum super elevation values are this: 7%, 7%, 10%, 4%. By default we take 7%. For plain conditions 7%. For urban 4%. For hilly terrain, not snow, it is 10%. But by default we take it 7% only. And minimum transfer slope should be camber. To ho gayi. Camber to we should provide for drainage. Okay, so we take 7% if nothing is given. So mix from here, if E1 is less than 0.07, okay, because less than 7% we can provide. Question and question. If E1 greater than 0.07, so from greater than 0.07 we don't take, so take 0.07 only. And now check for second step, check for mu. Mu is equal to V square by GR minus E. You have taken E, we have taken 0.07. If mu is less than 0.15, okay, because we have taken the maximum value of super elevation and we are finding the help of other value, help of other friend. If other friend required is less than 0.15, yes, that much he can provide help. Okay. If mu is greater than 0.15, which it cannot help more than 0.15, then we can take the maximum values of our friend 0.07 or 0.15 and reduce the speed. We restrict it and we put a signboard there that by this is the maximum speed which you can travel. I am repeating, guys, again. Although for this is subjective, for objective course you don't have to go beyond this, because in any case happening not okay, not okay, E will be 0.07 only. For objective case you don't have to go beyond this, because further whatever is happening, not happening, we changing, restricting, not happening, whatever happening, E is 0.07. So find E from here. If E less than 0.07, suppose 0.05, so answer will be 0.05. Suppose E comes 0.04, answer is 0.04. If answer is more than 0.07, we cannot take, so take 0.07 and check the value of other friend. Okay, V square by GR minus E, E is 0.07. If other friend requirement is less than 0.15, okay, it can provide it. If more than 0.15 is required, which it cannot provide, so take the maximum help of the friends and see whatever is the new velocity. Everybody give me yes or no? Okay, now this is the thing. Now there are two things: ruling minimum radius and absolute minimum radius. So guys, E plus mu is equal to V square by GR. So R is equal to V square G E plus mu. So R ruling minimum radius is V square G E max. With this minimum will be denominator's maximum 0.15. Okay, and absolute, if you have to go, if itne se bhi kaam nahi chal raha, we have to go even lesser radius, we have to go even for lesser radius, then nothing we can do. R absolute minimum, then we have to reduce, and already this is E max plus 0.15. Give me a son of everybody. Come on. Come on. Come on, friends, everyone on the comment section, please. Please. Got it? Any doubt? Okay. These answers that we have done. Now V by 9.5R, or if I go in SI units it should be 2.64. If I go in SI units it should be 2.64 root R. 2.64 in SI units. Okay. NL square by 2R plus V 2.64 root R in SI units. What is extra widening? Now please see. What is N, what is L? I'll tell you. If a road is like this, then every vehicle, suppose here is a building, here is a tree, every vehicle wants to travel from the outer side of the road. He doesn't want to go from here, because from here he will say only up to this distance. He wants to travel from the outer side of the road, because from outer side he will to say the large distance. Everybody wants to go from outer side so that he can see the large distances. Okay, from inner side he will not be able to see large distance. Let me show you from a picture now. Somewhere, yeah, this one. If vehicle is going from here, he can see only up to this distance. But if vehicle is going from here, he can see larger distance na. He can see larger distance na. So every vehicle wants to go from the outer edge to see from larger distance. So that is why inner lane is not used. So that's why we provide the extra widening, because inner lane is not using, for driver are using the outer lane only. So we provide the extra widening, that is called psychological widening. Psychological widening is V by 2.64 root R SI units. Now one is mechanical widening. What is mechanical widening? Suppose a road is like this, then on a curve what happens? If, guys, see, this is the wheelbase, this is a wheelbase, okay. If the outer wheel is at the edge, might be if the front wheel is at the edge, might the rear wheel may be out of the edge. Okay, so this much extra widening is required, that is NL square by 2R. N is number of lanes, L is the length of wheelbase. If not given, length of wheelbase will be taken as 6 meters upon 2R. Let me make you understand in a better way. Okay, guys, suppose this is a curve. Now a driver is moving a car. This is the car. Now I'll explain. Now this is the wheelbase. Length of wheelbase, if not given, we take it 6 meter. Okay. Now this is wheelbase. If the vehicle is here, if the wheelbase is also making parallel like this, parallel to road, it will be like this only. If the wheelbase is also parallel, okay, it is going here. If the wheelbase is parallel to curve, then if the front right wheel, right front is the edge, then the back side right also at the edge. But this is the condition when, wheelbase is moving like this. Okay, but can wheelbase move like this? Can wheelbase bend like this? No. Wheelbase will always be straight. Wheelbase will always be straight. So might be at any, for this position, this may off track. Okay, this may go off track. That off track value is L square by 2R. That off track value is L square by 2R. And for number of lanes we multiply by NL square by 2R. Okay, and somebody will ask you that why it is mechanical widening. Why it is mechanical widening? It is due to rigidity of wheelbase. If wheelbase is also like rigid, like flexible like this, then if front right wheel is at the edge, then the back right wheel is also at the edge. But wheelbase is not rigid, it will go off track. That is why we provide the extra widening. Everybody on the comment box, give me yes or no. Once, because if for any case we are not providing the radius from the ruling minimum, we have to go lesser. So for providing the lesser radius, E and mu cannot be more than the given values of 0.07 and 0.15. So we have only option is to reduce the V. Tell me. चलो 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 बताओ भाई. Any doubt? Okay. Now there is a transition curve, guys. See, everyone, this is a road and road is going like this. Okay, this is a road and then road is going like this. So to avoid the sharp turn at V point, this actually road we have not made, we are seeing only on the plan or map. To avoid the sharp turn, instead of going at V from T1 to T2, we draw a curve. Okay, then actual road now is this vehicle going like this, then this curve, then like this, and this curve radius is R. This curve radius is R. Now there is a big problem here. What is the centrifugal force? What is the centrifugal force? mv square by R. If we make a curve like this, okay, if we make a curve like this, then what is the centrifugal force just before T1? P before T1, when vehicle was in the straight line, P before T1 is 0 because radius is infinite, mv square by infinite. Radius of the straight line is infinite. Just after T1, it is mv square by R. So a vehicle moving at T1 there is no jerk, 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 and suddenly it crosses T1, there is a jerk. Okay, I am again saying vehicle is moving before T1, jadoo hai, nasa hai, no jerk, and as soon as crossed the T1, suddenly there is a jerk. Sudden mv square bar is coming. Sudden mv square bar is coming. So jerk is there. Centrifugal force will be coming very fast. And centrifugal force is coming, super elevation is also provided. So before T1 road will be like this because no centrifugal force. Just after T1 the super elevation will be like this. So vehicle will be jumping like this in a CD step. Okay, just before T1 there is no jump, and just after T1 there is a jump. Okay, so that will not look aesthetic. So to reduce this, to avoid this, we introduce the transition curve. What we do, instead of making a circular curve, what we do, we make a transition curve, this green color. We make a transition curve and then a circular curve. This is circular. Now what is this transition curve? Transition curve is a transition of radius. Here radius is very high, then less, then less, then less, then radius is R. Circular curve will be having a constant radius. Then radius more. Centrifugal force is mv square by R. So here R is not directly for infinity to R. Here the R is changing from infinity to R just at a single point T1. Here the R is reducing gradually reducing. So mv square by R is gradually increasing, gradually increasing. So jerk will not be coming as centrifugal force is coming gradually. So super elevation requirement will also be coming gradually. So it will not be like that. After T1 superelevation, this one, it will be like this. After T1, little bit more, little bit more, little bit more. Similarly, the curvature will be left and it will be straight line again smoothly. Okay, and the distance between them is shift. Distance between them is shift is ls square length of transition curve upon 24R. Okay, so this is transition curve. Have you understood? These are shapes of the transition curve. Now, on the basis of rate of change of centrifugal acceleration, this is equal to VQ by CR. V small letter, that means SI unit. And C is equal to 80 upon 75 plus V. Here the V is in kilometer per hour. Okay, C is a 80. This is on the basis of centrifugal acceleration. Now, on the basis of the introduction of superelevation, this is the formula. On the basis of empirical formula, this is the formula. Okay, of course, this is not in kilometer per hour. For plane, it is 35 V square by R, SI unit. And for hill, it is 12.96 V square by R, SI unit. These formulas might be for kilometer per hour. And from all these values, guys, shift I already told you. From all these values, whatever the maximum value is coming, that will be taking the answer. Either this or this. Sometimes, suppose this n is not given. N is the rate of change of superelevation. So, of course, then whatever the remaining formulas are there, on the basis of them, we will take the maximum value. Okay. Now, there is a curve resistance. There is a beautiful example, let me tell you, of curve resistance. Okay, see, suppose in a hill, now I am introducing hill also. A vehicle is going above. So whenever a vehicle is going in a hill, its speed is reduced because mg sin theta is acting downward. Mg sin theta force is reducing the force, correct? Correct, guys? Whenever a vehicle is going in a hill, its speed is actually reduced. Whenever a vehicle is going in a hill, its speed is actually reduced. Okay, the reduced speed is actually due to mg sin theta, which is pulling the vehicle. Okay, sir. So in hill, our speed is not more. Now, suppose I am going like this. Toing. So I am moving to right hand side because I have to go there. So my steering is attached to the right tires. So my right tires will be tilted first. My steering is attached, my steering is attached to the forward tires. When you rotate this handle, so these tires are rotated first. Okay, these tires are rotated first. Now if the engine are connected to the back wheels, in Wagoner, Swift, normally the cars, the engine is connected to back. In bikes also, guys, if you pull the rear wheel upward, the bike will not be able to move. If you put the rear wheel upward, the bike will not be able to move. Okay, because the engine is connected to the back wheel, rear wheel. Now, guys, the rear wheel will be providing the thrust. T is the thrust, like this. Rear wheel has not the brain, has not the senses, that the driver has rotated the tire like this. So that rear wheel has not the senses. It will be providing the T like this. And vehicle is going now in another direction. Let this be theta. So the force we are getting is T cos theta. Now thrust available by the engine is T. But we are getting in our direction is only T cos theta. Okay, so thrust is reduced, the tractive force is reduced, and what is the loss? T minus T cos theta. The vehicle has a power of t, but we are getting only t cos theta. Cos theta is less than 1. The reduction is t minus t cos theta. The reduction is t minus t cos theta. Okay, and two things are reducing our efforts. One is mg sin theta, and second is this, because that is also there, na? So that is why the two things are reducing our speed. When a vehicle is moving in a hill and curve is also there, curve gradient is reduced. Okay, curve gradient is reduced. That theta is reduced there, because otherwise there are so much forces which are reducing our power of vehicle. Maybe instead of going upward, that vehicle will come down and fall into the valley. Okay, so grade is compensated. Okay, grade is 4%, 6%, 6%, 6%, 6%, 6%. But whenever there is a turn in the hill, the gradient will be reduced, maybe 5%, maybe 5.1%. Okay, so the reduction is called grade compensation, and the reduced gradient now is compensated gradient. Okay, now how much to compensate the gradient? First of all, it says, the code says 4 points, that if the grade compensation is less than 4%, if grade is less than 4%, no requirement, no grade compensation required. It is already very, very less. Already it is very mild chadhai, very mild slope. No need to reduce the grade. Okay. If it is more than 4%, grade compensation required. If gradient is more than 4%, it is required. Now, the grade compensation will be minimum of 30 plus r by r or 75 by r, minimum of these two. And in any case, after reduction, you should not come below 4%. If gradient is suppose 7%, so you will reduce. But after reduction, it should not be less than 4%. Okay, after reduction, it should not be less than 4%. Suppose gradient is 3%. It is not at all required. No need to reduce the gradient, it is already reduced. Okay, so here the slope will be there, but here when the turn, grade is reduced. Again there will be some slope, but in the turn it is reduced. Give me yes or no. Give me yes or no, everyone. Have you understood? This everything is written here. Now let me ask you a question. Gradient is 1 in 20. Radius is 120 meter. Find grade compensation and compensated gradient. चलो चलो, if you forget the formula, grade compensation is minimum of 30 plus r by r or 75 by r. Do it. चलो come on, come on, come on, show some energy. 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 No requirement. अच्छा भाई, 1 in 20 is how much percent? 5% ना? 1 in 20 means 5%. 1 vertical in 20 horizontal. That means in 100 horizontal, 5 vertical. So it is 5%. So 5% means it is required. 5% means it is required. Five percent means it is required. Tell me answer, guys. Come on. Give your today's day to me. Give your today's day to me. I will make sure that you will get enough knowledge. Yes, good. Alekhya, Raj. What about Pooja? Vansh, good. Vansh. Come on. 1 in 20, na? So 1 in 20 means how much in 100? 1 in 20 means how much in 100? 5%. So it is 5%, so it is required. So grade compensation is minimum of 30 plus R by R, comma 75 by R. So what is this? 30 plus 120 by 120 and 75 by 120. What is these values coming? 30 plus 120 by 120 is how much? One thing also I forgot. Okay. Oh no, it's fine. No, nothing we have forgot. What is this? 1.25? This is 1.25, please confirm. And this is 0.75, please confirm. Or 0.625. Sorry, this is coming 0.625. So what is minimum? Minimum is this. So grade compensation, this value is 0.625. Okay, and compensated gradient is 5 minus 0.625, that is equal to 4.375%. That means on the road the gradient will be 5% and on the curve it will be 4.375%. Give me yes or no. Give me yes or no, everyone. Okay, almost more than 50% is complete. Okay, great. Please like the session, guys. And are you all coming in my OCF series also, guys? Today it is not there. Are you coming in my OCF series also? Monday to Saturday on app at 3:30 p.m. Monday to Saturday on app at 3:30 p.m. Yes or no? No. Okay. Complete OCF I am teaching there. Huh? Complete OCF I am teaching there. Okay. This you understood? Any doubt? This you understood? Okay, now guys, how many parts I told of this? See guys, total PPT is of 200, and out of 200 guys, how many we have done? It almost 50% is done. Okay, 90 PPTs we have done. Total is 200 slides, even more than 200. Okay, so almost 50% is done, and later 50% will take less time than this 50%, because geometry design has more derivations and more things to tell. In traffic engineering, even the PPT will be more, but will take lesser time. So already 50-60% of marathon has been done. Now guys, there are two types of vertical curves. What I was telling you, that there are 4 things in this chapter. Na? Where is that? 4 things in this chapter. Na? See, cross-sectional elements we have done, camber, carriageway and all. Side distance, SSD, OSD we have done. Horizontal alignment, super elevation, extra widening, length of transition curve we have done. Now vertical curve, that I already told you that it will take 10 minutes, where summit curve and valley curve is there. Okay, summit curve and valley curve. Do 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 do. Okay, now complete OCF guys, complete, exactly like paid course, exactly like paid course. Okay, shall we go forward? चले मचाएं कुछ? चलो, शेयर कर दिया आपने, like and share. Setback, because from last 8 years no question is there, so that is why I am not doing that. Okay, now see, there are 2 types of vertical curve. One is summit curve. Okay, summit curve means convexity upward. Example, flyover. Vertical curve, now different points will be having different elevation. And one is valley curve, one is valley curve. Valley curve example is, valley curve also called as sag curve. Example is underpass. Okay, here the convexity is upward, here the convexity is downward. Now how summit curve will be formed? Okay, when this is a summit curve, this is a summit curve, so initial slope is plus n1%, plus 2%, 3% is rising curve, so slope will be plus, and final slope is downward, so it is minus n2%. Okay, this is the deviation angle delta, and delta is n1 minus n2 ka mod. Delta is the deviation angle of here. Actual road is the white one, and convexity is upward. Of course, if this n1 is positive, and then it is 0, positive slope, 0 slope, then also it is summit curve, and in this case also it is summit curve. Now okay, let me tell this. Summit curve, when we are designing na, so summit curve we are designing on the basis of, let me just wait. Summit curve we are designing on the basis of side distance. Okay, here this is greater and this is lesser. Okay, here in summit curve, now what is the criteria, what is the difficulty? That vehicle traveling here should see the obstruction. Okay, should see the obstruction. Here it is not able to see the obstruction. Okay, so we have to design like this. Suppose obstruction is this, so now it is able to see the obstruction. So side distance is the criteria. Side distance is the criteria for length of what summit curve. Now there are two cases. First is suppose L is greater than S. S can be SSD, OSD, anything. S can be SSD, OSD or ISD. Suppose length of curve is greater than the side distance. Okay. Then the formula is this. Okay. Then the formula for length of curve is this. This is when L is greater than S. I'll tell you a question, then you'll understand. When length is greater than side distance, either SSD, ISD, OSD, it will be mentioned in the question that you are designing for SSD, you are designing for OSD, you are designing for ISD, but at least SSD you have to design. Then this is the formula. H is the height of driver eye and small h is the height of the object. Capital H is the height of driver and small h is the height of object. Now SSD, ISD, OSD. Capital H, small h. Height of driver eye is 1.2, 1.2, 1.2. In OSD, the vehicle has to see the vehicle only, na, coming from the other end. So height of object is also 1.2. In OSD, the vehicle should see the vehicle only, na. Okay, ISD has no physical meaning. But SSD, in SSD, vehicle has to see smaller objects also, na. Vehicle has to see smaller objects also, na. So this is 0.15. Okay. Everyone guys, everyone be attentive, full. So this is the case where length is greater than S. S can be SSD, ISD, OSD. That will be given in the question. That will be given in the question that you are designing the summit curve for SSD, for ISD or for OSD. So L is this. Okay. When L is greater than S, formula is this. And for H and H, if you put SSD, formula will be this. If you put OSD and ISD, formula will be this. If you put here, now this is the general formula. This is the general formula. If you put the codal values of capital H and small h, for if the question is for SSD, answer is this. For OSD, ISD, this is this. Now, second case, when length of the curve is less than the side distance. Length of the curve is less than side distance. S again can be SSD, ISD or OSD. Then the formula is this. Then the formula is this. L is equal to what is capital N? N1 minus N2 ka mod. This, and for various values of capital H and small h, answer will be this. So guys, in this there is no much concept. That is why I told that in vertical curve it will not take much time. Okay, now you will better understand this from a question. First of all, do this question. What is the deviation angle? N. I told you na, N1 minus N2. Okay, so what is N1? Initial gradient is ascending. Ascending means plus. With a descending means minus. Minus is, this minus is of the formula. And N2 itself is minus. So it is 1 by 100 plus 1 by 80 is equal to 400, 4 plus 5, so 9 by 400, A option. Okay, understood? And what is this delta? This delta is N. Initial gradient is plus N1, this is minus N2. Now this, how the question will be coming from this now. Let me take a question on this, then you will understand. Let me take a question on this, then you will understand. Okay. See. Find length of summit curve. Okay. Find the length of the summit curve for stopping side distance. For SSD, is equal to 180. So we have to design for SSD, not OSD, not ISD. And up gradient is 1 by 200 meeting a down gradient of 1 in 200. Do this. Down gradient. Now guys, which case you will apply? L greater than S or less than S? We don't know. So when we don't know L, S is 180. S is 180. But when we don't know that the value of L, how we will find that it is greater or less? So we'll assume L greater than S. So L greater than S, and this is for SSD. Question is asking for SSD. It is NS square by 4.4. What is N? N1 minus N2. So 1 by 200 minus 1 by 200. It is 2 by 200. It is 0.01. So L is equal to 0.01 into S square, 180 square upon 4.4. What is the value of L coming? 73.63. So what we have assumed, L greater than S. It is greater than S? No. L is less than S. 73.63 is less than 180. So not okay. Not okay. So now we will go ahead. Assume next case. L less than S. So less than S for SSD, the kahan gaya? For less than S, it is 2S minus 4.4 by N. 2 into 180 minus 4.4 by N is 0.01. So what is the value of L you are getting from here? Minus 80. Okay. The L value is coming to be minus 80. So whenever such values are coming minus from case 2, from case 1 never it will be coming minus. It is mod quantity positive, positive, positive. From case 2, if case 1 is not satisfied, then only you will be going to case 2. And in case 2, if value comes in negative, what it means? Otherwise, I can take a question where the value is coming 170. So it is less than S, answer is 170, fine. I can take that option, that question also. So whenever answer comes in minus, that means there is no restriction of side distance. For that particular very gentle gradients, 1 by 100 and 1 by 100, these are very gentle gradients and side distance is not there. From the first point you can see the last point very easily. There is no restriction of side distance. Okay, and a minimum length can be provided of 60 meters. And a minimum length can be provided of 60 meters. So this is a new type of question you must have been seen. Okay, so no restriction. If it is coming, no restriction. Give me yes or no. Give me yes or no, guys. Come on. Everyone, please share the session here. Come on. Everyone, please share it. Okay. Similarly, guys, valley curve na. Okay, valley curve is like this. So here a minus gradient is joined by a plus gradient. Here minus, then plus. Here minus, then plus. Okay, or plus. Here plus, then a bigger magnitude of plus, then also the convexity is downward. Okay, so valley curve, guys, there are two things which we design on the basis of two things, on the basis of comfort criteria, on the basis of headlight side distance. Okay, the headlight side distance, minimum headlight side distance should be how much? Guys, our headlight is like this, that it is going like happy dent ad is coming na, E karke, like when he do E, then a ray of light comes. Okay, so what should be headlight side distance means where we want to see. If it is going up to OSD, or here our headlight is going up to 500 kilometers from Delhi to Bombay, headlight is going, it's fine. But at least headlight should be going up to SSD, because we have to apply brake. SSD is critical. At least we should be seeing the object which should be at least more than SSD distance away. So we should stop early, and headlight should be going ahead. We should see the object early. At least SSD distance it should be there. Okay, L is 50. We can, here L is no value. Yeah, you can take it. Let us take, you would have just to write that there is no restriction of side distance. Okay, and let us provide a length of 50 meters. Okay, so here what happens, center is here when vehicle is moving like this in vertical circle. So mv square by r is there, downward, center is here, and mg is also downward. So guys, normal reaction will be here large na, normal reaction will be large na, because mv square by r is also acting downward, mg is also acting downward. Due to this both force downward acting, the normal force will be more, and maybe tire is burst, tire can be burst. So that is why the radius should not be less. So this is on the basis of that, rate of change of centrifugal acceleration. Okay, and the second criteria is that in daytime there is no restriction of side distance. A person going here can raise his mundi, can raise his eye, can see everywhere. But in night he can see only up to, this is headlight, he can see only up to the headlight side distance. Okay, so at night the side criteria will be there, that headlight side distance should be more than SSD. Otherwise side criteria, guys, in summit curve there is side criteria. Might be a person cannot see this, but in valley curve there is no side criteria in daytime, but in night time there is this. So due to this thing, increase in the downward force, so tire may burst, that is comfort condition, and due to this the valley curve length is decided and the maximum value is taken. So due to the comfort criteria, L is this length of valley curve, N is, capital N is N1 minus N2 ka mod, V is the velocity, C is the rate of change of centrifugal acceleration. C value will be given to you in the question. Okay, C is the value of rate of change of centrifugal acceleration. So this is the criteria 1, this one. Now this criteria, when greater than SSD, this is the formula. When less than SSD, this is the formula. Okay, from here one value will be coming from here, one value will be coming from here, then maximum value you will be taking. Maximum value you will be taking. Okay, now give me your feedback. Enjoyed chapter 1? Enjoyed? Feedback of chapter 1, guys. We have done building line, we have done control line, carriageway, camber, okay, SSD done, derivation done, OSD done, ISD done, superelevation done, extra widening done, length of transition curve done. Only setback distance is not done, and that reason also I told you. Valley curve done, sag curve done, or grade compensation done. Give me, have you enjoyed or not? Chapter 1 complete. Now 60-70% of the marathon is done. Around, guys, 65% of marathon done. Have you enjoyed? Tell me the feedback here, guys. Come on. Come on. Nobody. Nobody, guys. Come on, everybody. Tell me who are here from the starting of this marathon. Hi Pooja. Tell me who are here from the starting of the marathon. चलो 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 ओके प्रकाश, ये भी तो बड़ी कोचिंग है। सेंट्रिफ्यूगल ये रहा, एक बार शेयर कर दो सबके सब। प्लीज शेयर एवरीवन। ओके चलो, डायमेंशंस का क्या करोगे? देखो, एक चीज होती है, वन थिंग इज देयर पीसीयू, पैसेंजर कार यूनिट। ओके, व्हाट इज पीसीयू? व्हाट इज पीसीयू? एक बार मैं टेलीग्राम, आप भी शेयर कर दो यार, एक बार टीचर को थोड़ा मोटिवेशन रहता है, मैं इतना कर रहा हूँ आपके लिए। प्लीज शेयर, आप भी कर दो एक बार। मैं एक बार लिख देता हूँ टेलीग्राम में, चैप्टर 2 स्टार्टिंग नाउ। ट्रैफिक इंजीनियरिंग, please join okay guys, you all know my telegram group na? Everyone, ओके चलो, you want break? I'll give you break for lunch as well. I'll give you the break for lunch as well यार, don't worry. This is my link for the telegram group. Now guys, what is PCU? Now PCU did, see, every car is having a different dimensions. Okay, different class of the vehicles, dimensions are different. Now in this chapter we will not be talking about the radius of curve, the visible dimensions, the visible geometries we have talked. In this whole chapter I'll not be talking of super elevation, I'll not be talking of the width of the road, I'll not be talking of the radius of the curve, I'll not be talking about the side distance, I'll not be talking about any such point which is related to geometry. Instead, I'll be talking about the traffic. Now when I have to talk about the traffic, there are different traffic having different dimensions. So all these traffics are converted to passenger one particular dimension PCU. Okay. Otherwise, if somebody says there are 100 vehicles in the road and another says there are 200 vehicles in the road, so I will say yeah, 200 vehicles road is more occupied. But after the research, I got to know that when he is saying a 200 vehicles, all 200 are bike. And when the other person is saying the 100 vehicles, then all 100 vehicles are 50 tire wala truck. So maybe the 100 vehicles are more density than the 200. So that is why we convert everything into passenger car unit. That is why we converted everything into passenger car unit. Got it? Okay. Now, how to convert? Like you have seen, na, smaller things are having lesser PCU, then bigger things, truck, bigger PCU, and even the bigger vehicles are having the bigger PCU. How? There is a formula for PCU. It is capacity of road. It is capacity means how much vehicles are moving. Capacity of road when passenger car unit alone is moving on road. Passenger car is a car having a dimension almost same as that of Wagoner car. Okay, it is the almost same as that of Wagoner car, divided by capacity of road. What is capacity? I'll tell you. When vehicle of that class alone is moving on road, whose PCU is to be calculated. Okay, don't go in my writing, it is written here. The PCU value of vehicle may be considered the ratio of, it is written here, ratio of capacity of roadway when passenger cars only moving in the road upon when the vehicles of that class is only moving. Okay, so capacity means number of vehicles passing through a section. Okay, suppose here I sit and there are 300 vehicles passing in 1 hour, so I will say the capacity is, or the maximum number of vehicles passing can be 300 vehicles per hour. Okay, so if suppose in 1 hour the passenger car unit having a dimension approximately same of Wagoner, suppose 1000 such cars are moving from a cross section, then suppose I want to find for a bike. So how many bikes can go? More or less, if car can go 1000 from a cross section, car can go 1000 in an hour, bike will go how much? More or less? More. Suppose bike is going 2000, so PCU is coming 0.5 like this. Okay, similarly suppose I am calculating for truck. So suppose 1000 cars are going, now I want to find truck. So how many trucks can go? Maybe 250, 260 or 240, less will be. So that is why the PCU is coming is more. Have you understood, guys? Have you understood? Everyone? Have you understood? Please tell me. Please tell me. Okay. Now let me make you understand some speed, traffic speed, density and volume. What is traffic density? It is represented by K. It is number of vehicles in 1 kilometer. Okay, number of vehicles present on a specified length. Suppose density, if I say 300 vehicles per kilometer per lane. Because if there are multi lanes, suppose there are 4 lanes, so 300 vehicles are here in 1 kilometer, 300 are here, 300 are here, 300 are here. So I can say K is equal to 1200 vehicles per kilometer. So in 1 kilometer, 300 here, 300 here, 300 here, 300 here, or I can say 300 vehicle per kilometer per lane. This is just example. It is not necessary it will be 300. It can be anything. 300, 400, 200, 1000, 0, anything. Okay, so K is the number of vehicles per kilometer, per lane. One is speed, okay, how much speed it is moving, okay, that is simple speed, that whatever you know. One is volume, it is represented by Q. Okay, so Q is that suppose this is a road, you take a cross section here XX and you sit here. One vehicle will go, then after some time one more, then after some time one more. Suppose in 1 hour 800 vehicle goes. So Q is equal to 800 vehicle per hour. And of course this may be the case that this is the cross section 2 lanes. So 800 vehicles are going from here, 800 going from here. So you can say Q is equal to 1600 vehicle per hour, or you can say either 1600 vehicle per hour or 800 vehicle per hour per lane. This is just an example. It can be 1600, it can be 60, it can be anything, it can be 500, it can be 800, it can be anything. And maximum value of Q is capacity. Okay guys, Q can be changing. Now let me ask you something here. Guys, when K will be maximum? Tell me. When K will be maximum density? Density is vehicles per kilometer. When K will be maximum? Tell me on the comment box. Yes, Lakshmi, Prakash, Vas, Harshu, everyone. When K will be maximum? When K will be maximum? K will be K max. Maximum density will be coming when jam will be there. When jam density, that is called as Kj. When K will be maximum in case of jam density, when it is Kj. When it is Kj, it will be maximum that time. At the time of jam, guys, at the time of jam, there are maximum vehicles in 1 kilometer. At the time of jam, there will be maximum velocity at that time. When jam, what will be the velocity and what will be the volume? Tell me on the comment box. Yes, good. Boss. Please like the session, guys. Please like the session. At the time of jam, guys, velocity, there are still there will be, it is theoretically it will be 0. And what will be the volume? What will be the volume? Volume is also 0 because all are still. Volume is number of cross section, number of vehicles passing from a cross section. So no vehicle is passing. All are still. All are still. No volume, nothing is passing. Nothing is passing. Okay. So K is K max, that is jam density. Now if I talk about Q. Okay. So Q, guys, that is volume. That is volume. So when less vehicles like 2 AM, Q will be less because less vehicles will be, guys, in night less vehicle is passing, very less vehicles. And at jam also, jam vehicles are very much there but they are not passing, then also Q will be very less. So Q will be maximum somewhere in between. Okay, Q will be maximum somewhere in between because when there are very less vehicles, vehicle is going very fast. This is a cross section XX. Vehicle is going very fast but less number of vehicles in the night. And at jam, Q will be 0. In fact, 0 at that time. in fact 0 that time. So Q will be maximum somewhere in between, and the maximum value of Q is called as capacity. Maximum value of Q is called as capacity, and the relation between Q, K and V is Q is equal to K into V. Q is vehicle per hour, K is vehicle per kilometer, V is kilometer per hour. Of course the units are matching, that is why it is not a derivation. Otherwise if you write put 2 here, 3 here, 4 here, then also unit will be matching. Okay. So I'm not saying that this is a derivation. Okay. So Q is equal to KV. Okay. Now when K is maximum, jam, but velocity is 0 that time, na? So Q is 0. Okay. Now this all the theoretical things, I'm not going into that. Okay, this I can go. Guys, first of all, there are 2 things are asked in GATE, that for which hourly volume I design my road. See, for which volume I design the road, and for which speed, which percentile speed I design my road. Okay, so my friends, we design the road for 30th highest hourly volume. We design for 30th highest hourly volume. Hourly volume. Guys, see, number of hours in a year कितना होगा? Number of hours in a year, assuming that to be 365 days a year and 24. So every hour we collect the data, that how much is the volume, how much is the volume. Every hour we collect the data. So we have this much number of datas of hourly volume. Now we put them in descending order. This highest, second highest, third highest, fourth highest, 1, 2, 3, 4, like this. Then whatever is the 30th highest value, na, this is our design volume. We design for this. We design for this 30th highest hourly volume. Now you may say, sir, why don't you design for the highest? Guys, civil engineer has 2 eyes. Civil engineer has 2 eyes. One eye is economy and one eye is safety. One eye is economy and one eye is safety. If we design for the highest volume, might be at that time when Modi has come, and due to seeing the Modi, lots of people are coming. But every day Modi will not be coming now. So there is not a huge requirement of width. There is not huge requirement of lane. Might be one day it is blocked. But for that one day Modi coming at the time of election, you cannot provide every day these long or large widths, large number of lanes na. So that is for checking the design. Civil engineer has 2 eyes, economy and safety both. If you design for the highest hourly volume, you will not be economical. Okay, so for checking the economy and safety both, for seeing the economy and safety both the things, we design for the 30th highest hourly volume. Okay, I will tell you all these values also. Now, guys, a question has been asked. Percentage time in a year. This is a GATE question. GATE PYQ. Percentage time in a year when in road there is jam. When road is jammed. Guys, of course, it can be anything. I am asking number. Might be 0 time it is jammed. Might be all time it is jammed. But as per the design criteria, this is a GATE PYQ. Tell me on the comment box. Tell me on the comment box. how much time it will be jammed. How much time it will be jammed. For how much time it will be jammed, how much percentage time, if somebody has designed from the code values. See, 29 hours it will be jammed, na? Not 30 guys, for 30 we are designing. For 30 we are designing guys. So it will not be jammed because for this value we are designing. But for these above values we are not designing. So this is the time jammed and number of hours is 365 into 24 into 100. So this value is the answer. Whatever this is coming. Whatever this is coming. I will tell you what is AADT. Okay. So this will be the answer. Now, guys, see, speed guys, we take the data of speed of various persons. We take the data of various persons. Okay. Then, for what speed we design the speed? Tell me. For what value of speed we design the speed? Can anyone know? Guys, 98 percentile speed is design speed. Okay. The speed with which 98% drivers are running with lesser speed, that speed is taken as design speed. 85 percentile speed, 85 percentile speed is taken as safe speed. If a person is moving with 85 percentile speed, means 85% drivers are running less than that, it's fine, because we have designed our road for even bigger speed. We design a road for bigger speed, 98 percentile speed we design the road. 85 percentile speed is the safe speed, and 15 percentile speed is lower limit of speed. Okay. If a vehicle is moving and only 15% vehicles are moving less than that speed, then that is lower limit of speed. Lower limit of speed means these vehicles are moving very less now. These vehicles are moving with very less speed, so they should be segregated from the main traffic. Because of them there are chances of jam. Because of them other journey has been delayed. Okay, so these can be segregated from the main traffic. Okay, give me yes or no everyone. Come on. Okay, now coming to AADT. See, annual average daily traffic is the traffic of one day only. But for one day traffic, we have taken the average of 365 days. 1st January, we have taken the data. Okay. 2nd January, we have taken the data. For 365 days, we have taken the data and divided by 365. Now, the average of Virat Kohli can be different. Na? If we see the average of World Cups, it will be around 95. The average of Virat Kohli in subcontinent, in batting pitches, will be of course more. Average of Virat Kohli in inland will be comparatively lesser. Similarly, this AADT is average of 365 days. Every day we take the data. Every day we take the data and then we take the average of 365 days. So now this will be a very good data because this will include seasonal variation, because in 365 days everything is coming. Winter, summer, everything is coming. So seasonal variation will be written here somewhere. Okay. Seasonal variation will be coming here. Okay. Now this is average of only weekday traffic. So only the weekday data we have taken and we have taken the average. ADT means it is again daily traffic or one day traffic, but here only 7 days are taken. Less than a year. Generally 7 days or less than a year. It will not include seasonal variation. Okay. It will not include seasonal variation because might be you have taken the data in the month of summer. Then more number of vehicles will be coming. Might be you have taken those 7 days or 8 days in winter, then less value will be coming in. So might be you take the average of Virat Kohli in World Cup, might be more. Might be average of Virat Kohli in Indian pitches, maybe more. Okay, so this is the best data because this is the average of whole year. This is the average of only small period. Okay, average weekday traffic is again the traffic of average 24-hour data only on weekdays. But this is average annual weekday traffic, means weekday of whole year, January, February, March, April, May, June, all data. This average weekday traffic may be only on the month of May. Okay, so design volume, everything is done. Hourly expansion factor is total traffic volume of a day upon traffic volume of a particular hour. Now see, instead of counting the data for the whole year, okay guys, if we want to find AADT, this is the best data because this is the daily traffic, this is the daily traffic, but here whole year we have taken the data. Now if you want to do just by counting 1 hour data, okay, 1 hour data, maybe, what is today's date? Today is Sunday, December, 1 PM to 2 PM. I count data, example 500. Now I want AADT. Guys, for AADT we have to count the data for whole year, na? Every day 24 hours, then the average is taken. Now how? By only counting 1 hour I will do. See here, traffic volume of that particular example is how much? 500. We have counted only for 1 hour. We have counted only for 1 hour. 500. 1 PM to 2 PM Sunday, that is 17th December. Now suppose hourly expansion factor is given. This is given in codes for different areas. This is given. Okay, suppose this value is given as 20. That means total volume of today will be 20 into 500. It will be 1000. No, 10,000. Okay. Now for today value, what is coming? 10,000. Suppose daily expansion factor of Sunday. For Sunday, suppose it is coming 5 for Sunday. Then 10,000 into 5. So total volume of a week is 50,000. Total volume of week is 50,000. What is average daily traffic? 50,000 by 7 of 1 day. That 50,000 is for whole week. For 1 day, I cannot write AADT because this is only for 7 days. So it is the shorter duration period. See, this AADT is whole year. This ADT is for shorter period. Both are daily traffic. This is also daily traffic. This is also daily traffic. Virat Kohli average is both. But one average will be of all the matches, of all the countries, of all the tournaments. That is this. That is also average but of shorter. So this is a shorter thing, only of 7 days. So ADT is 50,000 by 7. So this is 50,000 by 7. Suppose monthly expansion factor of December. We have taken the data on December. Na? Monthly expansion factor of December is suppose 10. So this answer will be AADT will be 50,000 by 7 into 10. Understood? Now you will better understood with the question. You will better understood this with the question. Now just to make you understand this topic, tell me what will be the hourly expansion factor range. This range will be means around 11, 12, 13. It will be around 100, 200. It will be around 2 or 3. What is the range of this value? Just I want to know that have you understood this value? If you can tell me the range of this value now, so this value will be around 7, this value will be around 12, this value will be around 24, this value will be around 365. I will get to know that you have understood this. चलो come on, what is the value of hourly expansion vector? Yeah, range, tell me. Yeah, come on, everyone, please tell me, my students, everyone. What is the value of hourly expansion factor? Tell me, come on. Guys, multiplying this value with hourly expansion factor, we are getting the value of 1 day. So this will be around 15, 19, 24, 25 like this, na? Will be around 24, maybe 17, 18, 24, 25, 15 like this. Because by multiplying 1 hour volume with this, we get a whole day. So this will be around 24. Tell me this. Yes, Lakshmi Narayan. Tell me this. This value, average volume of a day, I am multiplying this, we are getting of a week. So this will be around 7. Correct? This will be around 7. Now tell me this monthly expansion vector. Yeah, this is trick. This, let me check who can do this. Why I am asking this value, just to know that have you understood this or not. If you can tell me the value or range of these expansion vectors, that means you have understood. Chalo. Chalo. You might be saying 7. Please check. Okay, guys, this value will be around 1. I have given 10, but this will be around 1 because this is also daily traffic, although it is average of 365 days. This is also daily traffic, so this value will be around 1. Guys, Virat Kohli average of all the grounds and Virat Kohli average of India will not be having a huge difference of 10 or 5 or 7. It will be around 1 or 1.5 like this. So this is also daily traffic, this is also daily traffic. So value will be around 1 only. Got it? Everyone, please. You want a question on this? Okay, later on we'll do. See, now this headway, space headway, and one will be the time headway, है ना? Okay. One will be the time headway, है ना? Let me explain this. See. One is time headway. There are 2 times of headway, na? Let me take new slide. I want to teach in new. See. Headway. Okay. This is time headway, and time headway let me represent with HI, and one will be space headway. one is space headway. Space headway, let me write with S or SI. Okay. Okay. What is now time headway and what is now space headway? Everybody please look here. Guys, keep sharing the session, guys. Come on, everyone. Come on. What is time headway? Suppose this is a vehicle. Suppose this is a vehicle and this is one more vehicle. Okay. This is traveling here. Now this is cross section XX. Suppose this vehicle goes at some distance, this vehicle 1 and this vehicle 2. Suppose T1 goes at T0 time. Vehicle 1 goes at T0 time and vehicle 2 goes from here at T0 plus HI time. So HI is time headway. Time headway is the distance between either bumper to bumper or rear to rear or center of mass. The distance between, not the distance, the gap between the two vehicles in terms of time. Okay. Gap between the two vehicles in terms of time. This is, let us second, this number of seconds per vehicle, this number of seconds per vehicle. Okay. Now guys, if HI is 2 seconds per vehicle, can you tell me the volume? If after every 2 seconds one vehicle is going, can you tell me the volume? Can you tell me the volume, guys? Everyone on the comment section. Everyone, please. Please, guys, come on. Tell me on the comment section. Yes, great. Come on, tell me the volume. Tell me the volume, guys. Come on, what are you doing here? Why no answer? Why you are not commenting? Guys? Should I stop the class then? At least reply ki you don't know. Okay. See, for every 2 seconds if one vehicle is going na, but the gap between the two vehicles is 2 seconds na, that means after every 2 seconds one vehicle is going. That means in 3600 seconds, in 1 hour, how many vehicle will go? 1800. So Q will be 1800 vehicle per hour per lane also, because this is in one lane. This 2 second gap is one lane. Might be there are 2 lanes. So here every 2 seconds one vehicle is going, but here also every 2 seconds one vehicle is going na? So 1800 from here, 1800 from here. So total will be 36,600. So this should be written as per lane. So the formula is H, this volume formula is 3600 by HI. If I put HI in seconds per vehicle, 3600 by 1800. So this you will be getting as vehicle per hour per lane. Give me everybody on the comment section yes or no. Have you understood or not? Have you understood or not? Everybody, guys, come on. Jaya, the headway is the gap between the two vehicles in terms of time. If one vehicle is going, another vehicle is going after 2 seconds or 3 seconds, whatever, let me assume 2 seconds. One vehicle go, another vehicle after 2 seconds, another vehicle after 2 seconds, another vehicle after 2 seconds, another vehicle after 2 seconds. So the gap between the vehicles is 2 seconds. So HI is second per vehicle. Okay, if it is 2 second example, this is example, not fixed. So after every 2 seconds one vehicle is going, that means in 1 hour 1800 vehicles are going. Please put a, guys, have you understood or not? Please tell me, yaar. Please tell me, come on. Okay, now this is the time headway. This is the time headway. Now let me go to the space headway. Space headway is the distance. The distance between two vehicles, either rear to rear, bumper to bumper, or I can say center mass to center mass. That is SI. Example, SI is suppose 10 meters per vehicle. So what will be the density? What will be the density? If SI is 10 meters per vehicle, what will be the density? In every 10 meter one vehicle is there. So in 100 meters 10 vehicle will be there. In 1000 meters there will be 100 vehicles. So density will be 100 vehicle per kilometer per lane. If every 10 meter there is one vehicle, so 100 meter there will be 10 vehicles. Okay, that is why per lane, na? That is why 20102 I have written per lane. So if every 10 meter there is one vehicle, so 100 meter there will be 10 vehicles, in 1000 meter there will be 100 vehicles. Okay, so density is 1000 by space headway. If this you write in meter per vehicle, then from here you will be getting vehicle per kilometer per lane. Got it? Got it? Hi सुदीप भाई कैसे हैं? Okay, please share sir. Okay, sideways spacing we have given. Okay, now guys, Q is equal to K into V. Now K can be written as 1000 by S. Density is 1000 by S into V. So this is the capacity volume. Maximum volume is capacity. So maximum volume will be when you put S minimum. Okay, maximum volume when S minimum. So S minimum, there are various options. So either the S minimum is 0.7 V plus 6. I told you in OSD. Or it is SSD, the minimum gap between the two vehicles. Or it is SSD plus length. Okay. So S minimum is these values, minimum of this, whatever is minimum. Okay, at according to what data in question it is given, because every time this formula is coming, sometimes they are taking this, sometimes they are taking this, sometimes they are taking this. So you have to see the data. If in data they give the longitudinal friction also, reaction time of driver also, then they want this. If along with that they have tell the length of vehicle also, that they want S minimum to be used this. If they have not given mu longitudinal, nothing reaction time, that means they were asking from this. Okay, so guys, there are majorly two types of speed, time mean speed, and this we have given 85, 90 we have done. One is desired line, means where there is more thicker line, that means that traffic, that road is used more. So even when we in future we want to make our data more, or we want to re-infrastructure our city, okay, then these data where there are thick line, that means it is used by more number of peoples, we can renovate them first. Okay, now we'll do just one question, time mean speed and space mean speed, MSQ question, then there will be a break. Okay, after that there will be a break. Okay, after break we'll do green shield and all these models. Okay, so time mean speed and space mean speed. Guys, time means speed is the average. There are so many vehicles traveling. Okay, there are so many vehicles traveling in the road. This. There are so many vehicles. Okay, let me just give me a minute. Okay, see, everyone, see, time means speed is whatever the vehicles are in the road, V1, V2, V3, V4, calculate the average speed of all. That is the time mean speed. Okay, that is the time mean speed. Okay, whatever the all speeds, take the average of all speeds. That will be the time mean speed. Space mean speed is Vs. There are various vehicles, one vehicle, second vehicle, third vehicle. Study them for 1 kilometer. Okay, and take the average speed. So one vehicle 1 kilometer, second vehicle 1 kilometer, third vehicle 1 kilometer. So 1 plus 1 plus 1 n number of times. This is the distance, n number of times. So distance, speed is distance by time, na? So every vehicle you have to check for 1 kilometer. So distance, speed will be, speed is distance by time. Time traveled by all vehicles. Time will be by first vehicle, time will be distance, that is 1 by speed of first. So time traveled by second vehicle, distance by speed of second, 1 by V3. So this will be this. Any doubt here? Okay, any doubt? And time mean speed will always be greater than equal to space mean speed, because time mean speed is arithmetic mean, space mean speed is harmonic mean. So arithmetic mean is always greater than equal to harmonic mean. Do this. Please. Do this, please. Time means speed and space means speed. Do you want a break? After that, I'm good, Gaurav. Do you want a break after that? Okay, so time means speed is, see, we can take this speed as 3, this speed as 3, 7, 11, 14. So time means speed is average of all. So 3 speed is by 1 vehicle. Then 7 speed is 7 plus 7 plus 7 3 times, plus 11 plus 11 plus 11 4 times, plus 14 plus 14 7 times, divided by number of vehicles. So 11, 15. What is this answer coming? And space mean speed is n, that is number of vehicles. 11, 14, 15 by distance traveled for 1 kilometer. So 1 kilometer with speed 3. So distance by speed is time. And how many such vehicles? 1. Then speed, distance 1 and time is 7. How many such vehicles? 3. Then distance 1 and speed is 11. How many such vehicles? 4. Similarly 7 and 1 by 14. So this is the total distance and this is the total time by all vehicles. Whatever the answer you are getting from here. Okay. Whatever the answer you are getting from here, I am not going in that. So guys, after this is poison and green shield model we have to study. Okay. Okay guys, this is my complete F-free series for OCF. Okay. Complete means complete. Complete means complete. Okay. 3:30 p.m. on app, but today there is no class. Monday to Saturday. (3:30 p.m. on app. Okay. Description video in description na there is a link of Abhinav Negi. You can download app from there. Okay. Break. Now we'll continue. Highway. In fact, the complete highway marathon from, what is the time? How much break you want? 13:47 to 15 or 2:20. 2:20 p.m. Okay. Okay. Okay guys, thank you. गारंटीड की स्पेलिंग गलत है भाई। इसको बंद करो यार। ओके, रेडी रेडी गाइस, everyone? Okay, so guys, just a small request, please share it, Vansh, Epic, I have no academy यार। ओके, मैथ्स को कैसे करते हैं? जैसे सारे सब्जेक्ट्स को करते हैं वैसे ही करते हैं, कॉन्सेप्ट पढ़ते हैं, क्वेश्चन करते हैं। ओके, प्लीज शेयर। ओके, चलें। Till now guys, have you got benefited? Please tell me, do you think that this session is beneficial to you? If yes, then we can come up with more such sessions. Okay, and OCF is going on guys. Okay, the complete OCF I am teaching on app. Monday to Saturday at 3:30 p.m. on app. You can join this and complete. Okay, and you can download the app from the link here. Okay. चलें फिर आगे। चलें, यहाँ तक कोई डाउट है तो बता दो। ओके, ग्रीन शील्ड मॉडल करना था एंड पॉइजन डिस्ट्रीब्यूशन करना था। पहले पॉइजन करते हैं। एनी डाउट टिल हियर? नो? Shall we move further then? Okay, see guys, probability of passing from a cross section, suppose it has given that this is a road and in this road this is a cross section XX. Okay, in this road there is the cross section XX and from this XX the various vehicles are passing, and the passing of those vehicles follows Poisson distribution. This is given. Now the probability of n vehicles passing in time t is given by lambda t ki power n e ki power minus lambda t by n factorial. Now what is here lambda? Lambda is the average value of vehicles that is passing through t times. It will be written somewhere here. Okay, not written. Lambda is the average value of vehicles that are passing, or lambda you can say, for if you multiplying lambda into t, lambda is the volume here in that case. Lambda is the volume. Okay, so the per hour lambda, so lambda t in t time. N is the number of vehicles, Lambda is the volume and n is n factorial. Once you do a question, then you will able to get this. Once you do a question, you will be able to go this. Let me do the question. An observer counts 360 vehicles per hour. An observer counts 360 vehicle per hour at a highway. Okay. Now assume that it is Poissonly distributed. Assume Poisson distribution. Vehicle arrival rate follows Poisson distribution. Then what we have to find the probability of having 0 vehicles in 20 seconds. Find probability of 0 vehicles in 10 seconds. Tell me probability of 0 vehicles in 10 seconds. Tell me guys, come on. Chalo, everybody, come on, champions. Show the energy again. Show the energy again, guys. Come on, everyone. Hit it. Everybody out there. Hit the questions hard. Hit the questions hard. Chalo. 360 vehicle per hour is the volume, lambda value. Lambda value is 360 vehicles per hour. And what they're asking? The probability of 0 vehicles in the next 10 seconds. What is the probability? What is the probability that in next 10 seconds 0 vehicles goes there? 0. Tell me. So it is 0 vehicles in time t. Lambda is 360 vehicles per hour into t. Our t is 0. Our t is 0. Okay, no, sorry, our t is 20 seconds. N is 0. Our t is 20 seconds. So this is per hour. So 20, convert this is also in hour. This is 360 vehicles per hour. So 20 seconds in hour will be 20 by 3600. Correct? Ki power n. N is 0. E ki power minus lambda. Lambda is 360 and time is 20 by 3600 upon n factorial. What is the answer coming? What is the answer coming, guys? Of this value? Okay. Come on, just tell me. Is it coming 0.135? Is it coming 0.135? Tell me. Guys, sometime one more type of question is coming. Okay, in this case, what is the probability that time headway is less than 8 seconds? For this question only, find probability that time headway is less than 8 seconds for the same data above. For the same data above, what is the probability that time headway, although here nothing is mentioned about headway. So how we'll do this? How you will do this? There is nothing mentioned about headway. This is the normal question here. Everybody is doing this. This is a normal question. Everybody just put the formula and get the answer. What is the concept here? Okay, put the formula, get the answer. What is the probability that time headway is less than 8 seconds? Tell me. Guys, we'll calculate later on that, but probability of time headway greater than 8 seconds, time headway greater than 8 seconds, that is equivalent to probability of 0 vehicles in 8 seconds. Please check. Time headway greater than 8 means in 8 seconds no vehicle is coming. In 8 seconds no vehicle is coming. Is it correct? Is it correct? So in 8 seconds no vehicle is coming. The probability is in see n is 0, so this will be 1 only. Okay, 0 vehicles. Now that e की power lambda is 360 by 3600 into 8 upon 0 factorial, that is 1 only. Correct? And probability of this is probability of headway 0 vehicle in 8 seconds. Okay, this is the probability of 0 vehicles in 8 seconds. So less than 8 seconds will be, what is this answer? This is the probability of greater than 8 seconds. So less than 8 seconds is 1 minus this, and greater than 8 second value is this. So that is 1 minus whatever the e की power, this, all this value. So what is this value coming? Suppose this is coming alpha r. So 1 minus alpha will be the answer. Have you understood this? Everybody? This is the trick question, na? This is the trick question. Now even they can ask this also, probability of time headway 8 to 10. So what you do? Find the probability of 0 vehicles, or find the probability of headway greater than 10 and greater than 8. Probability of headway greater than 8 minus probability of time headway greater than 10 and greater than 8. Subtract these two. Greater than 8, this will be greater than 8, and minus greater than 10. This will be 8 to 10. Have you understood the concept, guys? Okay, so everybody is doing this. Yeah, we have to go to this level also. Now this model I will tell you later on. First of all, let me tell you this. This is just means here I cannot teach anything like this. Here you have to learn this number of vehicles. Now this also you have to not learn, otherwise you have to make the diagram. If there are two roads, na, A and B, okay, this is A and this is B. Okay, now if the roads are both two ways, okay, the number of conflicts, okay, A one way and B two way, number of conflicts, both one way, number of conflicts. So in this data, na, the most number of data they are asking, both are two ways, okay, and this. And out of this, I guess 16, please check this, 16 are major, 8 are minor. 16 are major, 8 are minor. Now, how we decide that it is a major or minor? Can anybody tell me? How we decide that it is major or minor? How we decide that it is major or minor? Let me tell you. Guys, if relative velocity is high, that is a major. And if relative velocity is less, it is the minor conflict. Now when the angle, see, this is A vector, this is suppose V1 vector, this is V2 vector. Okay, this is V1, this is V2. Now they are colliding. So if this is V1, this is V2, so just see the concept here. See the beautiful concept. This nobody will tell you. This is V1, this is V2, so this is minus V2. If that is V2, that is minus V2. And if at one head I put one tail, if one vector's head I put one tail, so then this will be a summation V1 plus this. So V1 plus minus V2, that means V1 minus V2 vector. Okay, this is V1, and now suppose this is V1 and V2 is hitting like this, accident is like this. So V1, if V2 is like this, then minus V2 will be like this. So this will be V1 minus V2 is a smaller vector. Now see the logic guys. When the angle will be more, so this is V1, this is V2, so this will be minus V2 and this will be V1 minus V2. Relative velocity more. Relative velocity is subtract of the velocities, na? And if this is V1, this is V2, so this will be minus V2. So this is V1 minus V2, this is relative velocity. Here this is relative velocity, so here relative velocity will be bigger. So whenever the angle is more, that are major conflicts. Whenever the angle is less, these are the minor conflicts. Have you understood the physics behind this? Because I am 100% sure that 95% of the students are remembering only this. Why it is major and minor, they are not knowing. Major and minor is decided on the basis of relative velocity. And when the two vehicles are moving at higher angle, the relative velocity is more, v1 minus v2. Here, when they are coming smaller angle, this is this. Have you understood? Give me yes or no. Okay, so you have to remember this. All other data are not coming that much. Now, let me come to the green shield model. Okay, let me come to the green shield model. Let me delete this. Okay, everyone please see now very carefully. Okay, very carefully see what I am doing now. Everybody, green shield says that the relation between k and v is linear. Okay, Greenberg's has given the logarithmic variation. There are exponential also. Greenberg has given the logarithmic variation. Okay, there are exponential variation also. Okay, but as per green shield, from which most of the question comes as, is linear. Of course, this linear will be like this. Of course, this linear will be like this, because as density is more, velocity will be less. As more density in the traffic or in the road, velocity will be less. And here, when the density is maximum, kj, jam time, the velocity will be 0. As the density is more, of course the velocity will be decreasing. And here, when density is 0, the vehicle will be moving with free velocity. From 2-point problem, you can find the relation between v and k. Y minus y1 is equal to y2 minus y1 upon x2 minus x1 within bracket x minus x1. You can find the relationship. Now, I'm not going into that. Okay, you can find out the relationship. If you want, I'm not wasting time, and I'm just told the formula y, that is v minus v1 minus vf is equal to v2 minus v1 is equal to y2 minus y1 0 minus vf upon x2 minus x1 kj minus 0 upon x minus x1 k minus 0, like this. Now, from there we can find a relation between v and k, and if you put q is equal to kv, then you find a relation between the discharge and velocity also. Sorry, this is flow, volume, and here this is volume and k, like this, volume and k. Okay, now see, once you find the relation between v and q, it will be parabolic. From here, find the relation between v and k, then put q is equal to kv, that will be parabolic, and that parabolic relation will be like this. Okay, here it is q max, and when you differentiate that function now, that q max you will be getting at vf by 2. Q max you will be getting at vf by 2 when you differentiate. Now, why this function is like this? As velocity is more, see, q is the volume, vehicle per hour. So this is my section. When velocity is increasing, more fast, then volume will be more from this section. Volume is number of vehicles per hour. When velocity is less, so less vehicle will be passing from a cross section. When volume is more, then more number of vehicles passing from this cross section. At one time, after vf by 2, if further we increase the velocity now, frack, but next vehicle has to maintain a lot amount of gap, because if other vehicle is moving with 5 km per hour, you can move bumper to bumper. But if that vehicle is moving very fast, frack, the other vehicle has to maintain a large amount of distance, so that the spacing can be between them is such that if required, they can stop. Okay, so after a particular velocity, with further increase in velocity, it is not helping much, but जो नुकसान हो रहा है by providing a large amount of gap, that is more. So after that velocity, yes, vehicle is going very fast, frack, but more number of vehicles are not able to pass because other vehicle has to maintain a large amount of distance. Okay, and this maximum is Vf by 2. Similarly with K, it is like this. This is Q max, and Q max is coming at Kj by 2. Q max is maximum at Kj by 2. Okay, half of the density. This is maximum. Why? Guys, when there is no vehicle here, no vehicle in the road, volume will be less. As vehicle is more volume will be passing. But after one time, with further increase in the vehicles, the speed is reducing. So there are more number of vehicles in the road, but not passing from the cross section. Okay, so after that it will decrease. And this Q is equal to KV. So Q max, at the time of Q max, K is Kj by 2. At the time of Q max, it is Vf by 2. So Q max is Vf into Kj by 4, but this is only valid for green shield. Valid for green shield only. Valid for green shield. Okay, understood? Understood, guys? Do this question. MSQ. Everyone, please. Come on. Come on, come on, come on. Okay, what is this is the green shield model now, because linear relationship. Velocity is equal to 42.76 minus 0.22 K. So what is Vf? Vf is when density is 0. So put K is equal to 0. It is 42.76. What is Kj? Kj is when V is 0. 42.76 minus 0.22 Kj. So what is the Kj value? Please tell me, yaar. Please tell me, someone on the comment section. Someone on the comment section, please tell me what is the value of Kj? Tell me the value of Kj. Not telling. That will be 42.76 upon 0.22, yaar. Where is my calculator? I also have calculator. I bought new. 42.76 divided by 0.22 is equal to 194.36. Okay, jam density of road is 97.18. No, jam density is this. Maximum traffic capacity is Vf into Kj by 4 into Vf into Kj by 4. .75. This is correct. Jam density is this. Maximum traffic capacity of road is this. No. So B and C will be the answer. Okay. B and C will be the answer. Okay, this is okay. Mandatory signs means those who you have to follow. You have no choice. Like no horn, U-turn prohibited, only one side road, only one lane road. So all these are in circular shapes. The shape of mandatory sign will be circular. Cautionary means which are providing you to caution, like sharp bend ahead, sharp turn ahead. So all these are triangular shapes. And there are some informatory Informatory means which are providing information. Agra 20 kilometer, Delhi, like you have seen na, like this. Mangalore 51 kilometer, okay, like this. So all these are rectangular shapes. There are some exceptions like giveaways like this, top is of octagonal shape like this. Okay. Signal guys, only in gate na, only that Webster is coming. Okay. So Webster, it is the asking that what is the cycle length. So what does you mean by cycle length? That suppose guys, this is the intersection na. For this road, suppose it is green. So after how much time again the green will be coming? So one cycle is completing at how much time? Okay. So that is 1.5 into L plus 5 upon 1 minus Y. What is L? L is the total lost time. L is the total lost time. And Y is Y1 plus Y2 plus like this. Y1 is for lane 1 or any road. What is the normal flow upon saturation flow? Okay, तो इसको green दिखा दिया. इसके बाद किसी और को भी green दिखाते हैं. Once we show green to this, then we will show green to some other. For that some other, what is the normal flow upon the maximum flow, that is saturation flow. अब इसको green के बाद किसी और को भी green दिखाना है. यदि 4 रास्ते या 5 रास्ते या 6 रास्ते हैं, तो जिसको अब थर्ड को green दिखाना है, उसका नॉर्मल फ्लो अपॉन सैचुरेशन फ्लो, लाइक ऐसे कितनों को ग्रीन दिखाना है, उन सब का सम हो जाएगा कैपिटल वाई. यहां साइकिल लेंथ आपके पास आता है. ओके. नाउ रोटरी गाइज, इन रोटरी द व्हीकल्स आर गोइंग लाइक दिस. ओके. और द व्हीकल इज गोइंग लाइक दिस, और अ व्हीकल इज गोइंग लाइक दिस. Okay, so there are various ways a vehicle will go. Now guys, some important points of the rotary, let me tell you, advantage or disadvantage, whatever you can think, although it will be written somewhere. Okay, so you can see, but let me tell you, the advantage of rotary is that red light will not be there, vehicles can continuously move. Okay, need not to provide any electricity, it will not be based on electricity system, it will always be self-governing. Disadvantage is that guys, you may think that sir, if rotary we don't have to stop, then why always we don't provide rotary? The reason being very simple, because rotary is only feasible when the number of vehicles is 500 to 3000. If number of the volume is more than 3000, then rotary will be jammed. Okay, in that case we have to design signal only. Next, large area is required for rotary. Compared to signals, large area is required. Okay. Now, guys, one more thing that is there, that entry radius will be less than exit radius. Okay. What is this? Suppose this is rotary, na? Then when vehicle is entering from here and exit from here, this is exit, this is entry. So entry radius will be smaller than exit radius. Why? I want that when vehicle is coming to the rotary, the speed should be less. When vehicle is coming to the rotary, the speed should be less. So if radius is less, so radius less means sharp curvature. Sharp curvature, it will reduce its speed. But I want that the vehicles going from the rotary should go fast. So exit radius is more. So exit radius is more means smooth curvature. Although the difference will not be that much, but exit radius will be smooth curvature. And once the curvature is smooth, so vehicle can go with a larger speed. Okay, so this is the case. Now one more thing, that what is a weaving traffic? Okay, what is a weaving traffic? Suppose this is a road, A vehicle is going like this, B vehicle is going like this. Suppose A vehicle is going like this, and suppose B vehicle is going like this, C vehicle is going like this, and D vehicle is going like this. So weaving traffic means the whose path are intersecting, like B plus D, and non-weaving means whose path are not intersecting. There is a term weaving ratio. What is weaving ratio? The weaving traffic upon the total traffic. The weaving traffic upon the total traffic, that is the weaving ratio. Now these are all dimensions. This is the capacity of rotary. Okay, the capacity of rotary is 280 into W, 1 plus E by W, 1 minus P by 3 upon 1 plus W by L. In this, guys, only one thing that you will be worrying is P. All other values will be given. This is the capacity. Capacity means how much maximum, also called as Q, how much maximum traffic can be there. Only every value will be given, only P is the concern. Only P is the concern, and let me make it complete. Let me take a numerical. I have enough time, guys. Let me take a numerical. How the questions are coming from rotary. Okay, then only you will understand. Let me make it complete. Let me a question is there. Okay, width is equal to given as width of the is given as 15 meter. Okay, and width is given 15. Entry and exit width, it's E1 entry width is 10 meter. Okay, this is entry width also and exit width also. Okay, L whenever not given, now we have to take 4 times of W, so 60 meter. Okay, L is given as 60 meter. Okay, 4 times of W. Okay, W is not given. This is given. W is given as width of carriageway is given. Yaar, width of carriageway is 15 meter. Okay, the entry and exit width is 10 meter. Got it? And W is equal to E1 plus E2 by 2 plus 3.5. So E1 and E2 both are 10. 10 plus 10 by 2 plus 3.5. So W is equal to 13.5. L is equal to 4W. So L is equal to 54. Actually, that is even not required. Okay, L is equal to 54. Now the Q formula is 280 into W, 1 plus E by W, 1 minus P by 3 upon 1 plus W by L. This is the capacity of rotary. Now here W is known, L is known, P हमें निकाल, W, L, E everything is known. L is this, W is this, and E is this. So only we think is required P. P में ही सारा दिमाग है. North से जो इधर जाएगा, that is 375 number of vehicles in 1 hour. Here it is 650. Here it is 408. From W, the vehicle going here is 400. Here it is 505. Here it is 510. From S, it is 420. It is 350. And it is 370. And for East, this is 600. this is 500 and this is 250. Okay, we have to find, this is the rotary between. Now what does all this data means? I'll telling that also. What does all this data means? I'll be telling that also. Okay, okay, everyone ready? Ready? Okay, then let's go in an alto. Okay, now see guys, first of all, what is 375, what is 650? I am telling you all these. Suppose this is the north, this is east, this is south, this is west. First of all, what is, let me tell you what is 420. 420 is going like this. 350 is like this. What is 370? 370 is like this. Okay, want some more? Okay, vehicle in here only move clockwise na. Suppose let me tell you what is 400. 400 is like this. What is 505? 505 is like this. 510 is like this. Okay, so now you understood the meaning of that data. Now guys, we will be calculating the weaving ratio, the P, here, here, here and here. For those 4 P's I will find 4 Q's. Of course the minimum will be our answer, because for more than that there will be jam of remaining 3. Okay, so we will find P here, P here, P here, P here. Now guys, P means P, let me find here. Okay, P and W. Let me find P and W. So P is the weaving traffic upon total. First of all, tell me total traffic which is reaching there. So all traffic from W will be going there. Okay, from N no one will go there. 375 will go here, 650 will go here, 408 will go here. For north, no, nothing is going here. From east, guys, only 600 is reaching there. 600 is reaching there. And from south, 350 and 370. 350 and 370. Okay, now what is the weaving traffic, guys? Actually that every traffic can weave here. Suppose this 400 is going like this. Now I am saying 400 will go like this. 2, 2, 2, 2, 2, 2, 2. So every traffic can weave otherwise. Every traffic can weave here. Every traffic can weave. So whenever we are saying the weaving, that we will write only those values that have to weave in any case, like 505. 505 with 350 will weave 100%. There is no other option that it will not weave. So 505 and 350 will always weave. Okay, this is the total traffic. Out of this, 505 and 350 will weave. Nobody can stop them. Okay, similarly this 510, okay, this 510 and 350 will be weaving 100%. Okay, this 350 and 510 will weave in any case 100%. Even 600, which is coming from here, will weave 100%. 100%. So guys, one more thing. I am saying this, that here 400 will not be weaving. Now you tell me from which it will weave. 400, from 400 it will not weave. Although 400 can weave also, going like this. But once there is an option of making a diagram where it is not weaving, it will not weave. 400 will not weave with 350. I can make like this now. So once I can draw without weaving, then I will be considering that non-weaving also. Otherwise, every traffic can weave here. So 400 is not weaving. So sir, we have to make all the data like this. Every time you have to see. No, there is a shortcut. There is a shortcut for that. What is that shortcut? Suppose you want P and W na. So just come one leg before that. W. From W, whatever going to the next, that is 400, will not weave. All other will weave. This is a trick. Wherever you are finding the weaving ratio, just come one before that, W. From W going to the next, 400 will not weave, all other will weave. From W going to N will not weave, other will weave. From others going to N only weave, N only will weave. From here going to next, that is N, will not weave, others will weave. From other going to N only will weave, 350 going to N and 600. Like this. Like this. Like you calculate P for all, find the Q, and the minimum Q will be the answer. Give me yes or no in the comment section. It will be coming 3890. Give me yes or no. Everybody guys, come on. Come on, come on. Tell me please here. Tell me please. Have you understood? Everyone? Give me yes or no. Give me yes or no. Okay, how numerators will be calculated now? This weaving traffic, suppose I am calculating here. So just come one leg before that, W. From W, traffic going to N, that is 400, is not weaving. All other from W will be weaving, 505 and 510. From other legs, traffic going to N only will be weaving. From here, traffic going to N will not be weaving, others weaving. From here going to N will be weaving, 350 will be weaving, 600. Like when you are calculating here, so traffic from N going to E will not be weaving. Other traffics from N will be weaving. And from other legs, traffic going to E only will be weaving, 505 and 370. Okay. Now 3 and 4 I am doing on one because this is more theoretical. Not much concepts here. You have to study on these topics with your own. So I am only dealing with the conceptual topics of those. Okay. I am only dealing with the conceptual topic of these two. Any doubt? So we here enjoying. Now going to the last chapter 3 and 4. Okay. Flexible. What is flexible? What is rigid? Let me make a new slide. I don't enjoy guys and teaching in this. Or I more enjoy teaching in blank slides. See, what is flexible pavement? What is rigid pavement? I'll tell you. First of all, see, in chapter 1 we have seen the visible dimensions of the road: radius, super elevation, width, stopping side distance. Okay, we have seen there the visible dimensions. Now here in chapter 2 we have not done anything with dimensions. We have done with the vehicles, number of vehicles we are talking of. Now in pavement design chapter we will be more dealing with the thickness of various layers and the things from which the thickness will be identified, wheel load and all this. We will be more concerning on that. Okay, so flexible pavement means at the top surface it is bituminous surface of bitumen. Okay, and after bituminous surface it is base course and sub base, and below it will be subgrade, natural soil. Subgrade, this is soil and these are aggregates. Okay, now rigid pavement. In rigid pavement the top layer will be a concrete surface. Okay, this is subgrade, this is sub base or base course, and above that will be concrete surface. Above that will be concrete surface. Okay, so guys, let me see if I have a photo of them. Okay, no photo. Okay, flexible pavement means, guys, flexible pavement means, okay, those in which na the top surface is of bitumen, that black color generally you will be seeing. Okay, the black color loads are generally the bitumen. Okay, and rigid pavement, guys, are those where the top layer are of concrete. Okay, and generally when the vehicle goes on rigid pavement it will sound more. Okay, you generally enjoys moving on the flexible pavement only. In rigid pavement it looks or sound is coming off more when vehicle is moving. Why that is rigid? Because Young's modulus of concrete is much higher than the bitumen. So if Young's modulus is higher, so strain value, deflection values will be lesser. Okay, strain values, deflection value will be lesser. That is why they are called as rigid pavement. Otherwise, nobody in this universe is rigid. Strain will be small, will be very, very small, but not zero. So nothing is rigid. So comparatively, it is called as rigid. Now, guys, the cycle, the life of the concrete pavement will be more. Okay, but initial cost will also be more here. Here, maintenance cost will be more because it wear and tear very quickly. It will not wear and tear quickly. So maintenance cost will be more here, but initial cost will be more here. Now how these layers are designed, the top will be bitumen, then aggregates, then soil, top will be concrete, then aggregates, then soil, on a simple concept. Guys, when P load is there, as we go down the area is increasing. So A1 is more than A2, there is more than A3, then more than A4. This is A4, this is A3, this is A2, this is A1. So you know that A4 is greater than A3, is greater than A2, is greater than A1. So least stress is A1. So sigma 1 will be more, then sigma 2, then sigma 3, then sigma 4. That means sigma 1 is more than sigma 2, then that means the top layer the stresses are more. So that is why the stronger material should be at top. At the bottom layer the less stress is there. So even the weaker materials can do there. Okay. Okay. Everybody, same is the case with the rigid pavement. Now guys, there is a term called rigidity factor. Rigidity factor is contact pressure upon tire pressure. Contact pressure means which is coming from here, from the ground. Okay, this is the tire. Okay, the contact from the ground and tire pressure is inside this. If rigidity factor, if contact pressure is 7, okay, if contact pressure is 7, this is a rigidity factor. When contact pressure is, see, generally we just take this value as 0.7 only. If this value is 0.7, it will be 1. If this is greater than 0.7, it will be greater than 1. If this is less than 0.7, it will be less than 1. Now let me tell you the logic, guys. If this is the tire, actually tire is total, I cut it from here. If contact pressure is more and tire pressure is less, TP is less and contact pressure is more, net force has to be 0, na? So this is more, this is down, so net force, it will be coming downward. So this is compression on the tire, na? So tire comes in compression. Obviously, when tire pressure is less in cycle in childhood, when pressure is less, it comes in compression. Okay. Now, let me take, this is the tire. I cut the tire from here. This is the contact pressure and tire pressure will be more here. Tire pressure is more than contact pressure. Net force has to be 0. Net force has to be 0. So tire pressure is more, contact pressure is less. So downward force is more, upward is less. So making equilibrium, upward force comes like this. This is now tension. So when tire pressure is more, it comes in tension. Correct? When we put more air, it comes in tension. Now what is the equivalent single wheel load concept, guys? See here. If, guys, you have seen tires like this. Okay, this is the wheelbase. And sometimes in between there is 2 tires like this. So these 2 tires I am showing here. These 2 tires I am showing here because these 2 tires will cause some stress. These 2 tires having P and P load will causing some stress. Now I want to convert this in equivalent single wheel load, ESWL. And that equivalent single wheel load will produce the same stress that these 2 are producing. So that is the meaning. You understood by formula, na? You understood the formula, but that is the actual meaning. Equivalent single wheel load is that load which is producing the same stress as these by these 2. So suppose the clearest distance between them is D. Here the clear distance between them is D and center to center is S. Then up to, if we make a graph, this graph is log P and log depth and log ESWL. So code says that up to a depth of D by 2, equivalent single wheel load take P only. Okay, up to here the all layers, coarse aggregate, base aggregate, bitumen, whatever is designed for P only because stress is not overlapping. So at any point the load is P only. So design these layers for P. For greater, this is up to the depth D by 2. For the depth greater than 2S, this is log. Now log 2S, greater than 2S. For greater than 2S, the overlap is such that design it for 2P. Okay, log P, log 2P. So these is designed for P and below this it is designed for 2P. And in between these layers are designed from this interpolation. Okay, log P dash will be fine from this interpolation. So the top D by 2 below this tire, the D by 2 distance below, the layers will be designed for P load only. 2S below it will be designed for 2P and in between it will be designed for this interpolation. Give me yes or no. Give me yes or no, everybody. Come on. Understood? Understood, friends? Please tell me. Everyone? Okay. Achha, it was given here. Okay. Now guys, there is one more concept, that is EWL, equivalent wheel load factor. Guys, we divide every load there are various loads. Okay, 80 kilonewton, 100 kilonewton, 120, 140, 160. There are various loads. Okay, so we divide or we convert every load into 80. Okay, we divide every into single axle 80 kilonewton load. How to divide? Suppose there is a 20 kilonewton load. So divide into 80 by P1 by P. Standard is 80. Ki power 1 by 4. Suppose this is a load of 40. So convert in 80 by this factor. 40 by 80 ki power 4. Ki power 4. Convert everything into this. Let me give you an example. Standard axle load is 80. Now let me give you an example. On a survey weight in kilonewton, frequency, okay, midpoint, EALF, equivalent number of standard axle load. Okay, this is given. Total number of vehicle is 400. This also given. Total number of vehicle is equal to 400. Now find number of repetition of standard axle and find out the vehicle damage factor. This is a question. Okay, so weight in kilometer is also given na? 0 to 40, 40 to 80, 80 to 120 and 120 to 160. The values are 50, 250, 400 and 250. Now everyone please concentrate. So midpoint of 0 into 40, 0 and 40 is 20, this is 60, this is 100, this is 120. So ELF is 20 by 80. So 1 by 4 ki power 4, correct? Then it is 1 by 4 ki power 4. Then it is 3 by 4 ki power 4, 100 by 80, 5 by 4 ki power 4 and 140 by 80, 7 by 4 ki power 4. Okay, now 1 by 4 ki power 4 into 50, 1 by 4 ki power 4 into 50, 1 by 4, 1 by 256. This will be 25 by 128. Now 3 by 4 ki power 4 into 250. This will be 625 by 8. 5 by 4 ki power 4 into this. This will be 152625 by 16. Sin by 4 ki power 4 into number of vehicles. That is this. This is 2344.72. Now this total value is 3400. Okay. Okay. So this sensor number representation second 3400. Now what this means, sir? What does this calculation means? We are not getting that. We are not getting that, sir. What does this calculation mean, sir? Tell us that na. Tell us that na. What does this calculation mean, sir? Correct question? Correct question? What is this calculation? This calculation means, write down in your copy, guys. Write down in your copy. Write down in your copy. This calculation means that 80 kilonewton standard axle load, okay, traveling 3400 times will make the same stress that all these vehicles are moving this much number of times. So we converted every load, every frequency into 80 kilonewton because we have standard charts available. for the thickness required and other criteria for the 80 kilonewton. So all the data, different weight, different number of frequency, 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 all those things are converted into 80 kilonewton. All those things are converted into 80 kilonewton. Have you understood? Have you understood? Everyone, these number of vehicles, this number of weight, this number of times, 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 traveling in a road will cause same effect as 80 kilonewton will be traveling 3400 times. This whole data will make that much that 80 kilonewton will be making 3400 times. And what is vehicle damage factor? Vehicle damage factor 3400 divided by 400, it is 8.5. So even this large amount of calculation is not required. Even this large amount of calculation is not required if somebody gives us vehicle damage factor. By doing all this, we are coming here that these vehicles will make effect same like 80 kilonewton moving this much times. Even if this all data is not given, if total number of vehicles is given and VDF is given, just multiplying by VDF by this number of vehicles, we get this. Okay, so either one way is doing all these things. Second way, if VDF is given, then just by counting the number of vehicles and multiplying with VDF, we get the number of repetitions of standard axle load. Everybody on the comment box, give me yes or no. Everybody on the comment box, give me yes or no. Please, friends. Please. Everyone. Everyone. Tell me, please. Okay. Now, this everything we have done. CBR, I guess this is group index. Okay, finding out the group index value. Point this empirical 0.28 plus 0.001 BD plus 0.005 AC, where A value is P minus 35. What is the P? Percentage particles finer than 75 micron. We have done this in soil mechanics also. B is P minus 15. Percentage, then this minus 15 and should not be greater than 40. Okay, similarly this should not be greater than 20 and this should not. We have done this in soil mechanics. Finding the group index value, greater the group index value, poor the quality of the soil. Okay, CBR value is calculated. We take the sample. Okay, from within that sample, whatever the CBR value we want, might be we want CBR value of aggregate, we want CBR value of anything. Okay, or bitumen. So what is the CBR percentage value? Two values are fine, 2.5 and 5. So CBR values are find out the okay, the load required for 2.5 mm penetration upon the 2.5 mm penetration of standard material, that is 1370 na, I guess. Okay, in 200. Now CBR, this is CBR 2.5. Okay, load required for penetration of 2.5, we put a sample here, and load required to penetrate 2.5 mm of needle upon the standard load 1370 in 200. Similarly, CBR 5 is load required for penetration of 5 upon the standard material 2055. For standard material, that is crushed stone, it is 2055 in 200. Okay, so from here the CBR 2.5 and CBR 5 value are coming. Okay, whatever. If CBR of 2.5 mm penetration is more, it is reported as CBR value. But if 5 mm is more, then we repeat the test, and again in the repetition test 5 mm is more, then we adopt this. Okay. For 2.5, even if come more at one time, fine. But if CBR 5 value comes more, we repeat it. Okay, again repetition it comes, then it's okay. And what we find, we do to find the thickness from the CBR value. Okay, this is the formula for thickness of the layers above that from the CBR value, but that doesn't come in the gate examination. What is modulus of subgate reaction? P by delta. Okay, force divided by the deflection. This is the radius or relative stiffness. E. This has been asked one time in gate. Okay, not much physical significance. Okay, but this has been asked one time in gate. Okay, now equivalent radius of resisting section. Guys, see, when this, suppose this is a plan, this is tire. So tire touching with the ground is not circular, na? This, if I zoom, the imprint will be like this, na? It is not circular. But if we want to convert the imprint, the resisting section, how much area is resisting this, into circular section, the area resisting this load into circular section, then the radius is given by this. Okay, then the radius of this circular section B is given by this formula. Okay, this is the Burbiston method for finding out the deflection for rigid and this. Now these are the stress, guys. Okay, at corner, winter in this is the combination. We'll take some different class for that. Okay, we'll take some different class for that. One formula was there, future wala na. For this load combination, we'll do, I provide the notes, because everything there is for future वाला formula था ना कि बाद में कितने होंगे, number of this, number of vehicles, हाँ, n number of vehicles after some time. It's because we have to predict now, we are making the road for 20 years, 25 years. Okay, so we should we should be knowing that after 20 years what is the load, what is the number of vehicles. So that is 365 into A into 1 plus r ki power n, 1 plus r ki power n minus 1. From one load it will be multiplying by lane distribution factor. This is the total load. But if there are various loads, then various lanes, this is the total traffic. So from all the lanes, all the total traffic will not go na. From all the lanes, the total traffic will not go na. From one lane only partial traffic will go. So this we multiply by LDF. Okay. And if present traffic is given, then A is equal to P 1 plus R ki power X. X is the construction period. A is the volume on the first year of the construction of road, and P is the traffic right now. P is the traffic right now. X is the construction year. Then you can multiply it with VDF also for number of axles. This is number of vehicles. If you want number of axles, then number of axles are multiplying the number of vehicles into VDF na. I just told you. Okay. So guys, this we'll do in some other class. This is the session, guys. Okay, on YouTube, that is coming from Monday. Richa ma'am is coming for environment at 8:30 p.m. with her 10 questions. Okay, then the remaining subjects will be there. Richa ma'am will be on environment at 8:30 p.m. Okay, and this OCF series is going on for mine, guys, where I'll be teaching complete OCF for free. Complete OCF for free, guys. Okay, complete OCF I am teaching here free. Okay, from 0 level, you can see. Okay, so complete OCF will be here free. And guys, in the description box now of this video, there is a link. Abhinav Negian link will be written. Okay, Abhinav Negian link will be written. You can click that and download our app. This is my Telegram group. Here I'll be providing the notes. Just in 2 minutes, I'll provide the notes here. Yes, I didn't see your notes. Lakshmi, clear now? 400 is given, Lakshmi. In that question, 400 is given, number of vehicles. 400 is given, number of vehicles. Hi, Lakshmi. 400 is given. कहाँ गया? 400. This is given. Okay. Guys, enjoyed this? Want some more classes? You can tell me. कॉन्सेप्ट वाला हमने सारा पढ़ लिया भाई. कॉन्सेप्ट वाला सारा पढ़ लिया है. Okay. Thank you guys. Thank you all. Should I share my Telegram group again? This is my Telegram group. Okay. Thank you guys. Take care. Thank you. Take care all. Thank you.